Hello everyone and welcome back to Deeksha Karnataka YouTube channel, and today I am bringing the most expected video for you, what you have requested for multiple times, that is physics most expected MCQs in one shot. More than 200 MCQs in this lecture, one lecture for all the MCQs, all your MCQ requirements will be completed today. This is not the supplementary for Chakravyuh or Brahmastra, they are independent series. Here we have hand-picked few important MCQs from all the chapters and we are going to discuss. So even if you have following our Chakravyuh series, you should must watch this video. Also, if you are following Chakravyuh series, you cannot skip that as well, because there we are doing a much more elaborated MCQs, right? So this is most important MCQs, and if you watch this, most of your MCQ related problems will be solved. Also, I am giving you what all we have planned throughout this week. We have already given you model paper 2, model paper 1 solved last week, and already model paper 2 is available, and today will be physics all marker questions, that is one shot recording. Tomorrow will be physics PU2 all numerical questions in one shot. Friday will be physics all 5 marker questions, one shot. Then Sunday we will have passing package for the students who are struggling to get the passing marks. Okay, at least 30 to 40 marks will be guaranteed if you see that videos. That will be only for the students who are struggling. And then we will have Sunday physics all 2 and 3 marker questions. So Sunday there will be 2 physics videos. Okay, if you watch all the videos, definitely you will be very good position to secure at least 60 to 65 marks in your PU board exam. 5 marks question, God help us, there is a we cannot guarantee that out will be there, but yes, 65 marks definitely you can score if you watch all these videos. Okay, and passing package is specially for the weaker students who are struggling to get the passing marks. Now let's start with the series. Question number 1. The electric field at a distance r from an infinitely long straight uniformly charged wire. So uniformly long charged straight wire electric field is basically lambda by r. Electric field is basically lambda by r, depends on lambda by r. So you can say that it is inversely proportional to the only r. Okay, for a long straight wire electric field is only inversely proportional to r. Right, now next, which of the following charges is not possible? Let's see, this is the charge of an electron, this is just double of that, that is also possible, and this is 4 times of that, so this is also possible. But if you see, this is not an integer multiple of 1.6, right? This is a not integer multiple, so definitely it is not possible. It is 3.5 times, right? So 3.5 times is not possible because all the charges has to be integer multiple of the charges. So this is a HOTS question. So you need to apply some knowledge. This is not direct a knowledge or understanding based question. This is, you have to apply your understanding to find the answer. So that is why it is a higher order thinking level question. Now third question, the electrostatic force between two charges in vacuum is given by F is equal to K Q1 Q2 by R square, where K is what? 9 into 10 to the power of 9 Newton meter square per Coulomb square, 9 into 10 to the power of 9 Newton Coulomb square per meter square, 9 into 10 to the, obviously these two are not the answer. Out of these two will be the one of the answer, because here if you see 10 to the power of minus 9. Right, now how, if you ask me to guess, I can guess the answer to be option A. Why I guessed? We know that it is 9 into 10 to the power of 9. Now if you see, in 2 options they have given the same unit. In 2 options they have given the same unit, another one is a different unit. So this is how you can guess. Okay, maybe they tried to confuse us with the unit in one case and with 10 to the power value in another case. That is why I will guess this will be the correct answer, because we know it is 9 into 10 to the power of 9. The magnitude part we are clear. Unit part you can guess it like this way, or how can you guess? So how can you be sure that this is correct answer? So F is equal to K Q1 Q2 by r square. Now what is F? F is force. So what is that overall unit of this? Overall unit must be Newton, right? So overall unit must be Newton. So K, what is the unit of Q1, Q2? Q1 is Coulomb, Q2 is also Coulomb. So Q1 and Q2 will be Coulomb square, right? 2 coulombs, and in the denominator we have distance. Distance means meter, so it will be meter square, and the overall total unit should be, as I said, should be newtons, right? Now you just need to do the cross multiplication, so you can find the unit of K. So Newton meter square by Coulomb square, or Newton meter square per Coulomb square. So obviously you can find it that way, that option A is correct answer. Now question number 4. The direction of electric field vector at a point on the equatorial line of a dipole is. So direction of electric field vector due to an electric dipole on the equatorial line. So this is the equatorial line, minus Q plus Q. Okay, just let me change it so that you get the usual value. So this is, say, plus Q, this is minus Q. Okay, the dipole moment is from negative to positive, right? Dipole moment is from negative to positive, and if you remember that the dipole moment due to this system is basically in this direction, right? So dipole moment and electric field are in the opposite direction. So dipole moment and electric field are in the opposite direction. So if they ask you the direction, it will be in the opposite direction. Okay, opposite direction of the electric dipole moment. If they ask you about angles, the angle will be, what will be the angle? If the same question comes with an angle, the angle will be 180 degrees. Okay, so be careful. If they ask you on the axis of a dipole, if it is on the axis of the dipole, the angle will be 0 degree and they will be in the same direction. So one question, multiple possibilities are there from the same question. Now let's move on to the next question, question number 5. Name the physical quantity which has the dimensional formula L T A. Okay, what is L? L is distance. Okay, T is time, A is current, right? So current into time is what? Current into time, we know that this is basically current into time. Charge, the dimension of charge is A into T, and if you multiply it with the distance, then we get LAT, right? So LAT must be the dimension of dipole moment. Okay, it must be the dimension of dipole moment. Okay. Question number 6. Dash placed in an electric field experiences a force in the direction opposite to that of electric field. So only if you are considering the electric field, a positive charge placed in an electric field will experience the force in the direction of electric field. A negative charge placed in an electric field will experience a force in the opposite direction of the electric field, right? So all the positive charges faces the electric force in the direction of electric field, negative charges opposite to that of electric field. Now is there any negative charge given in the option? An electron. Electron is a negative charge, so definitely it will experience as a force in the opposite direction of the electric field. When a free electric dipole placed in a non-uniform electric field, the dipole will experience. So what is the type of electric field? Electric field is non-uniform. So if the electric field is not uniform, then the dipole will experience a force as well as a torque. Okay, so both force and torque, it will experience both force and torque. If it is only an uniform electric field, force will be 0, there will be a torque, right? So but in non-uniform electric field, both torque and electric force will be present. Okay, because the electric field is not uniform, so the net force will not cancel each other. Question number 8. Electrostatic field lines can never form closed loops. This is due to conservation of charges, conservation of momentum, quantization of electric charges, conservative nature of electrostatic field. So these three are basically properties of charges. Okay, but this is about electrostatic field. So from there you can guess must be option D, conservative nature of electrostatic field. Now let us understand this question. So in case suppose this is a positive charge, okay, it starts at positive, electric field line starts at positive charge and ends at infinity. Okay, if they were closed loop, so that means after infinity it comes back to the positive charge, then whatever work you have done from this, the work done will not be constant. Okay, so work done will not be the constant. That means in one path you are doing some work to take it in the infinity, in the other path there is no work is done. So basically the work that you are doing is not conserved, that means electric field is not conservative if this was happening. But because electric field is conservative in nature, okay, it is not possible. Thus this is due to the fact that conservative nature of electric field. So basically this is the answer for this question. You have to remember this answer. Now SI unit of electric flask. So what is electric flask? Electric flask is electric field into area. What is the SI unit for electric field? SI unit for electric field is Newton per Coulomb. What is the unit for area? Area is meter square. So electric flask is Newton meter square per Coulomb. Newton meter square per Coulomb. That is option C. So they have given the options cleverly to confuse you. Newton per Coulomb meter square. Now Weber is a magnetic field, unit for magnetic flask. Okay, not electric flask. Weber is the unit of magnetic flask. So don't get confused there either. Also Newton, so they have changed the order. So they have done it in this way: Newton Coulomb inverse meter square. Okay, so the order is slightly changed, but don't get confused. So this is the answer for this question. Question number 10. Electric field intensity at a distance r from center of uniformly charged sphere outside the sphere is E. Which of the following is correct? So we have a charged sphere and we are trying to find the electric field at a distance r outside the radius of the sphere. So this is r. So electric field for distances greater than r is basically given by k q by r square. Okay, so q is the total charge of the sphere, right? So it is directly proportional to q and inversely proportional to 1 by r square. So correct answer is option C, right? Directly proportional to q and inversely proportional to 1 by r square. Now next question. The electric field due to an electric dipole at any point on its axis which is at a distance r is very greater than length of the dipole from its center varies according to E proportional to r, E proportional to 1 by r, E proportional to 1 by r square, E proportional to 1 by r cube. So electric field due to a dipole, be it on its axis, be it on its equatorial plane, it will always be proportional to 1 by r cube. In case of equatorial plane, it will be negative of that, because we know that electric field and dipole moment are opposite direction, but magnitude wise they are always proportional to 1 by r cube, no matter what is the type of where you are measuring the electric field. Now question number 12, it's a miss and match the following type question. This is also comes under HOTS question. Okay, this is also a HOTS question because you have to apply knowledge, then applying the knowledge you have to find this, then you have to find the answer. So this is also type of HOTS question. So if you have any doubt what is the HOTS question, what is the meaning of HOTS question, you have to answer 4 HOTS question throughout the entire paper according to the blueprint shared by the board. Different chapters are there for your HOTS question, but there should be total number of 4 HOTS question. In MCQ section there will be 1 HOTS question in your numerical section as well. Now some physical quantities are listed in column 1 and SI units are listed in column 2. Identify the correct match. So how can we do that? First of all, we will try to find, as I said in my previous videos as well, you have to find whatever you know. Okay, so for example, electric field is volt per meter. That is a secret unit of electric field. It is not always Newton per coulomb. It is a secret unit, volt per meter. And what about electric flask? Electric flask is, if you multiply electric field with area, you should get unit of electric flux. So that should be volt into meter. Voltmeter is another secret unit of electric flask. Permittivity must be this one. Okay, permittivity must be this one, that is epsilon. Okay, epsilon naught. So this is the unit. This is how you can match. So 1 with B and 2 with C. So 1 with B and 2 with C is sufficient because it's only 3 match the following. So you can easily say that, okay, 1 with B, 2 with C, 3 definitely will be with A. So option A is the correct answer. So you need to know the relationship between the quantities. You need to know what are all the alternative unit for some quantities. For example, electric field is volt per meter. It is coming from the fact that electric field is basically dV by dl. Okay, so electric field is volt per meter. Now, statement based question, very popular these days. The electric field lines never crosses each other. Yes, correct statement. If the electric field lines crosses each other, the field at the point of intersection will not have a unique direction, which is not possible. So electric field lines basically represents not only the direction of electric field. If you draw the tangent at a point, it points the electric field at that particular point. Now if two electric field lines has to cross, then at that point of intersection we would have two different direction. But electric field is a vector quantity, so it should have only one unique direction each and every point. So that will not be violated, that will be violated. That is why electric field lines cannot cross each other, right? So this is the correct statement, and statement 2 is the correct explanation as well. So both statements are correct, and statement 2 is the correct explanation of statement 1. So option A is the correct answer for this. Now sometimes you have to check, I have seen that they have alternated the option A and option B. So be careful, read the statement carefully before marking the answer. Even if you know that both statements are correct and it is correct explanation, you have to check the options as well. They are doing some tricks in the options as well. Okay, now this is a question. 4 charges are placed at the corners of a square PQRS as shown in the figure. The direction of the resultant electric field at the intersection of the diagonal is. So you have to find the direction of electric field over here. Now as you can see that, what is the 3 charges? The charges given here are +2, +2, +2, and there is a -2. Okay, so first let us see. If we keep a positive charge over here, whatever the direction of force experienced by this positive charge, that will be the direction of the resultant field, right? So how can we do that? So here we have a +2 nanocoulomb, here also +2 nanocoulomb, here also +2 nanocoulomb. So we will see the effect of plus. So this and this will be basically, this one will repel it in this direction, this one will repel it in this direction. Both have same magnitude, so they will basically cancel each other out. Okay, now if you consider this +2 nanocoulomb, it will again repel it in this direction, right? It will be repelled, getting repelled by this +2 charge. Now what about this -2 charge? This -2 charge, again it will attract it. It will be getting attracted, so it will be attracted in this direction, so they will add up. So what is the net direction of electric field? Net direction must be in this direction, so it will be from P to R or O to R. Okay, so it will be towards R. It will be towards R. Electric field will be towards R. Why? Because in this case these two forces will cancel each other, but these two forces will add up in the same direction, so it will be towards R. Electric field will be towards R. So whenever they ask you to find the electric field, always use your best friend, a positive charge, to find the direction. Okay, to find the direction, positive charge is your best friend. Now next question. The following figure shows the electric field around two charges where Q1 is positive, Q2 is negative. So there are few combinations are given. Q1 is negative, Q2 is positive. Both charges are positive, both charges are negative. Let's see the diagram first. So here we have two charges, and if you see that both charges are having lines going outward from them. Okay, only one type of charge they have outward field lines each and every case. So what type of charge it is? Both charges must be positive in nature. Both charges must be positive. Only positive charges always have outward electric field line. If one of them was inward, one of them was outward, then one positive, one negative was possible. But because both of them are outward, that means they must be positive. If you see in the exam that both charges are inward, both field lines are inward, both charges for both cases, then it would be both would be negative charges. Okay, so you have to remember that for positive charge, electric field lines are always outward. So both charges are positive. So option C is the correct answer for this. Now next question. Equal charges are given to the two spheres of different radii. The potential will be more for bigger sphere, be more for smaller sphere, be equal on both spheres, depends on the nature of the material of the spheres. Now, what has this said? Equal charges are given, and one is a smaller, another one is bigger. So suppose this radius capital R, this one is smaller. Now what is the electric field on the surface or even inside the sphere? Electric field is 0 inside, electric field is 0 inside, potential is constant. Okay, potential is constant. Now what is the potential for this case? Say V small r, it will be K Q by R, right? Both spheres are given same charges. What will be the potential for this? Potential for this will be K Q by capital R. Now as you can see that both of them are given same charges, so the top part is same for both the cases. This one has a smaller denominator, this one has a larger denominator. So larger denominator means smaller the number, so definitely we can say that V small r is greater than that of V capital R. So V smaller must be greater than V capital R. So it will be more for smaller sphere. So electric potential will be more for smaller sphere. Now next question. The dimension of electric polarization is given by. So electric polarization, very interesting quantity. So electric polarization is given by also there is another definition here, by the way. This is called electric susceptibility. Okay, same as magnetic susceptibility, dimensionless quantity. Now another dimension of electric polarization is dipole moment per unit volume. Okay, so dipole moment per unit volume is the second definition of electric polarization. Now what is the unit of dipole moment? We know that unit of dipole moment. Now what is the meaning of that? You can check my Decode NCERT series. I have discussed it about that. Now dipole moment is basically coulomb into meter, right? We know that in unit, and volume per unit volume, that means it will be m cube. So dipole moment per unit volume means it will be coulomb meter to the power minus 2. That should be its unit. Or dimension wise, what is the dimension of coulomb? Dimension of coulomb is 80, and meter square, meter to the power minus 2, that is it will be ATL to the power minus 2, or L to the power minus 2 A into T. Slightly tricky question. If you don't know this question, you will not be able to answer. So better to remember this value. If you have difficult memory to remember how to find the dimension for this quantity, this is a very common question I am seeing in 2-3 different areas. So maybe it might come. So you have to remember this dimension, okay, dimension for electric polarization. Next question, the electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volt. The electric potential at the center of the shell is. So as I said in our previous part that potential remains constant throughout the conductor, inside the conductor. So electric potential remains constant, and this constant goes from center till the surface. From the surface onwards it starts to decrease. Okay, so inside the spherical shell or spherical conductor, if it is a conducting surface, potential remains constant. Okay, so potential remains constant means so both cases it should be 20 volt only. So 20 volt should be the electric potential at the center of the shell. Now next question, 19. The electric field at a point which is very close to the surface of a charged conductor with surface charge density sigma. Okay, so electric field at a point very close to the surface of a charged conductor is sigma by epsilon naught. Sigma by epsilon naught for any charged surface. For normal charged surface it is sigma by 2 epsilon naught. Okay, for any charged surface it was sigma by 2 epsilon naught, but for conductors it is sigma by, for conductors this value is, for conductors it becomes sigma by epsilon naught. So very confusing sometimes, but you have to remember for conductors this is the value, for normal surface sigma by 2 epsilon. That is why we use this one while trying to find the expression for capacitance in case of a parallel plate capacitor, because parallel plate capacitors capacitor pages may not be conductor always, right? So for conductor the value it is also given in your NCERT textbook. If you follow it you will know that for conductors it is sigma by epsilon naught, for any other surface it is sigma by 2 epsilon naught. Question number 20. The energy density between the plates of a charged capacitor is given by, very easy question, half CV square is the energy of the this, and this one is the energy density. This is energy density, this is energy stored. Okay, so be careful if they ask you energy, energy density only they said, no, my mistake. In total energy stored is half CV square, whereas energy density is half epsilon naught E square. Okay, so this is the relationship between energy density and electric field as well. If you have seen 2 marker questions, this is a very common 2 marker question as well. Now next question, the potential energy of an electric dipole placed in an uniform electric field is. So you have placed electric dipole into uniform electric field and you are trying to find the potential energy. Potential energy is basically the dot product of dipole moment and electric field. It is nothing to relate with this. These are for capacitors. For dipole only minus P dot E is the answer, or minus PE cos theta. You have to remember electric dipole potential energy is a scalar quantity, so it cannot be the cross product. Cross product is not possible. Now, next question. An electric dipole is placed in an uniform electric field. The dipole moment makes an angle theta with the electric field. For what angle theta is the potential energy of the dipole maximum? So in the last question we have seen that potential energy is minus P dot E, right? What is P dot E? P dot E is basically PE cos theta. Okay, PE cos theta. Now when it will be maximum? When cos theta is maximum. So when is cos theta maximum? Cos theta will be maximum, potential energy maximum value means this entire thing, if you can make this entire thing positive, that will be the maximum value. Now you have to see that if you put 0 you will get minus PE. If you put 45 you will get some minus PE by root 2. Okay, this is for 0, this is for 45. For 90 you will get, it will be 0, right? Cos 90 0. And for 180 degrees if you see, it will be minus PE into minus 1. So that is plus P. Now if you see which one is giving you maximum potential energy, They have not have talked about magnitude. So if you see, this one is positive PE, so positive PE must be greater than negative PE, right? So that means it will be maximum for angle 180 degree. So this is a very trick question. I think last year or last to last year this question came in an MCQ question. So be careful, it will be not 90 degrees, not 0 degrees, answer will be 180 degrees, right? In this case, potential energy of the dipole will be maximum. Now, capacitance of a capacitor is defined by C equals to Q by V, right? A factor on which the capacitance of the capacitor depends is charge Q, geometry of the conductor, potential difference V, all of the above. So many students reading my live session when I was doing Chakravyuh live session, many of the students actually answered all of the above. Actually that is not correct. Capacitance is independent of charge, capacitance is independent of potential difference. Even though the capacitance is defined by Q by V, but in reality when you measure the value of the capacitance, it is independent of the Q and V. It can adjust based on how much charge you have stored in the capacitor. Based on that, it will have a different voltage, but the ratio will remain constant. And for a parallel plate capacitor, we know that it depends on K A epsilon naught by D. K is the dielectric constant, A is the area, epsilon naught is a constant, that is free space permittivity, and D is the distance between them. Now A and D together basically defines the geometry of the capacitor plate, how much area of the capacitor, what is the distance between the plates, right? So based on that you can say it is basically geometry of the capacitor, nothing else. Now capacity of a parallel plate capacitor can be increased by increasing the distance between the planes, increasing the thickness of the plates, decreasing the area of the plates, decreasing the distance between the plates. Again the same formula, capacitance is basically K A epsilon naught by D. So how can you increase capacitance? Either you have to increase A, or you have to increase K, or you have to decrease D. Okay, nothing to do with the thickness of the plates. Individual thickness of the plates has nothing to do with. So only way is to decreasing the distance between the plates. If you decrease the distance between the plates, capacitance will increase. Question number 25. The potential energy of a capacitor is stored in the dash between the plates of the capacitor. So it is stored in the electric field. Okay, so higher the electric field, more charges are stored, more energy is stored. Okay, so that is why it is electric field. And if you see the expression for energy density of the capacitor, energy stored in the capacitor, energy density, that also comes out to be half epsilon naught E square, right? So basically this shows you that the energy is stored between the electric field, right? Now, which of the following correctly describes the behavior of polar and non-polar dielectrics in an electric field? Both polar and non-polar dielectrics, so this is a correctly describes, that means 3 of them are incorrect, only 1 is correct. So nowadays we have seen the type of questions where they are asking you mention the incorrect type, right? So they have giving you 3 correct statements and 1 incorrect statements, and they are asking you find the incorrect one, right? So that was little trickier, but here 3 of them are incorrect, only 1 is correct. Let's see. Both polar and non-polar dielectrics have permanent dipole moments. No, only polar dielectrics have permanent dipole moments. Polar dielectrics align their dipole moments within the external field, while in case of non-polar dielectrics, a dipole moment is induced in response to the electric field. Yes, this is the correct statement according to me. Let's see other 2 statements as well. Non-polar dielectrics align their permanent dipole moments. Obviously non-polar dielectrics do not have permanent dipole moments, so obviously this is also cancelled. Polar and non-polar dielectrics behave identically in the presence of electric field. That is also not correct. So as we can see that polar dielectric, they have a permanent dipole moment. They align their dipole moments based on the applied electric field, whereas non-polar dielectrics, they generally do not have any dielectric moment. They do not have any dielectric moment, but when you apply electric field, their dipole moments, there is an induced dipole moment and then they align. Okay, so option B is the correct answer. Now, next question. An electric dipole is placed inside an insulating spherical shell. Okay, so electric dipole is placed inside an insulating spherical shell. Say plus, minus. Okay, pick the wrong statement. Net charge enclosed by the shell is 0. So what is the net charge enclosed by the shell? Net charge enclosed by the cell, that is plus q minus q is 0. Now again, as I said, there you have to pick the wrong statement. So 3 statements are correct, only 1 is incorrect. That is why it is interesting question. Sphere acts as an equipotential surface. Electric flux through the sphere is 0. Electric flux is 0. Obviously electric flux is 0. We will check this statement later. Let's see other statements first. Electric field is not uniform across the surface of the spherical shell. So electric field is not uniform across the surface of the shell. Yes, electric field, see, if you see that electric field will be different in this side and also different in this side based on the angle which you are finding. So electric field at every point, it will be different. Okay, so it will not be the same on the shell. Okay, on the surface of the shell. So you can say that definitely the incorrect statement is option B, sphere acts as an equipotential surface. In fact, this one and this one are contradicting statement as well. So if this is true, this cannot be true. If this is true, this cannot be true. Okay, so but we have found this is true, that means this cannot be true. If electric field was constant on the surface of the sphere, then it would have behaved like a equipotential surface. But unfortunately, it will not behave as an equipotential surface. Now, next question. The following graphs show the variations of two physical quantities with distance r from the center of uniformly charged spherical shell. Identify the graphs. First graph shows the variation of electric field versus r, and second is V versus r. Okay, so we have given two graphs here. As you can see that there is a constant value up to this point, then it is decreasing. So definitely this is related to electric potential, and here electric field was 0 inside, suddenly it is increasing. So this basically represents electric field. So first graph shows variation of V versus R, and the second graph shows E versus R. So option B is correct answer for this question. Now, statement 1. The electric field inside a conductor is 0. All the charges reside only on the surface of the conductor. Obviously, all the charges reside on the surface of the conductor. That is why electric field inside the surface is 0. Okay, both statements are correct, and statement 2 is the correct explanation for the statement 1. Both statements are correct. Obviously both statements are correct, and it is the correct explanation, so option A is correct. Now I have made one mistake in this, so that is this one. Okay, why I have made a mistake? Because it said that electric field is not uniform. Okay, now electric field will be uniform in this case. Why? Because it is close integral E dot ds, that should be equals to qn by epsilon naught, right? So what is thing is, now ds cannot be 0, so only way it is En is 0, so 0 by epsilon naught q enclosed is 0, so electric field will be 0. Okay, electric field is 0. So electric field 0 means even if it is 0, it is a constant, it is uniform, right? Electric field 0 means it will be an equipotential surface. It will be a equipotential surface because E is basically dV by dl, right? So we can say that V will be constant. If you do the integration of 0 is constant, so V will be constant. That means sphere acts as a equipotential surface, but electric field is not uniform. Sorry, electric field is uniform, so electric field not uniform is wrong statement. My mistake, but I have corrected this. So those who are commenting, sir, you have made a mistake in the comment, so I have corrected this mistake. Okay, now let's move on to the question number 30. An imaginary sphere of radius r is drawn around a charge q. Keeping the charge q at its center, the work required to move a test charge small q from point A to point B is. So how much work you have to do if you want to move a charge from here to here? This is a again indirect question. Direct question would be what is the work done in an equipotential surface. So basically if you see this is a q charge, that means the potential on all the points of the sphere will be same because they are all equidistant. We know that formula for electric potential is kq divided by r. Now this r is same for all the points on the surface. That means all the points on the surface have the same potential. So basically you can consider this sphere to be an equipotential surface, and work done to move a charge on the equipotential surface is 0. Okay, so work done will be 0. It is not q into 2r or any other formula. It will be simply 0. In the absence of an electric field, the mean velocity of free electrons in a conductor at absolute temperature T is. So in absence of electric field, no external electric field is applied. So what is the mean velocity of the electrons in a conductor? So in the absence of electric field, drift velocity will be 0 because current will be 0. That means the mean speed will be 0. Mean speed, very careful. Individual electrons will still move, but when you take the average of all the motion, it will be 0. Okay, now next question. Ohm's law is valid when the temperature of the conductor is very low, very high, constant, varying. So Ohm's law is valid when temperature is constant. Okay, and it is there are some certain materials for whom you cannot apply Ohm's law, but if that is a ohmic conductor and temperature is constant, definitely Ohm's law will be valid. Now question number 33. In the equation AB equals to C, A is current density, C is electric field, then B is. So A is current density is J, into B we do not know, and C is electric field. Okay, so what is the meaning of this term B? Now we know that J equals to sigma E. This is another form of Ohm's law, right? Now what is sigma? Sigma is called conductivity. So from there we can write E is equal to J, current density J, divided by sigma, right? What is 1 by sigma? 1 by sigma means 1 by resistivity, 1 by conductivity. So 1 by conductivity is basically the resistivity. So E is equal to rho J. So here this constant B is basically the resistivity rho. It is the resistivity, not conductivity, not resistance, not potential difference. It is resistivity. Now the relaxation time in conductors increases with the increase of temperature, decreases with the increase of temperature, is independent of temperature, changes at 400 K and above. So definitely this will not be the correct answer. So either it will remain independent or it will change based on the temperature. Okay, now what is relaxation time? First let us understand that. Suppose we have a conductor, okay, it has lot of free electrons inside it. All the electrons are colliding with the neighboring electrons. Okay, they are always fighting to occupy space, so they are colliding with each other. Now between two collisions there is a time gap. Okay, between two consecutive collisions there is a time gap, that is called relaxation time tau. Okay, so now this relaxation time tau is basically inversely proportional to temperature. Why? Because if you increase the temperature, the electrons will start vibrating more. That means more vibration means the relaxation time decreases, right? So basically when temperature increases, collision increases, relaxation time decreases. So it decreases with increase of temperature. Okay, so relaxation time in conductors decreases with increase of temperature because it is inversely proportional. Now question number 35. With the increase in temperature, the conductivity of semiconductor increases and metals decreases. So as you increase the temperature, Okay, conductivity of semiconductors increases, and that of the metals or normal regular conductors, that decreases. Okay, so obviously you can see that option A is first one is the correct answer. So we have first come first serve basis, so we can see that first option is correct, so we do not need to look for any other options. Okay, drift velocity of electrons is due to motion of conduction electrons due to random collisions, motion of conduction electrons due to external electric field E, repulsion of the conduction electrons due to inner electrons of ions, collision of conduction electrons with each other. So drift velocity is basically when you apply an external electric field, the electrons started to drift in the opposite direction of the applied electric field, and those electrons are obviously conduction electrons. Conduction electrons can only move. Okay, valence electrons are tightly bound with the nucleus. Only the conduction electrons can carry the electric field. So basically it is motion of the conduction electrons due to the electric field E. The resistivity of a metal wire increases with the length of the wire, decreases with the area of cross section, decreases with the length and increases with the cross section of the wire, increases with the temperature. So as we know that resistivity of a metal wire depends on two things. Okay, only two things, not what you are thinking. It depends on the material and it depends on temperature. Okay, resistivity does not depend on length, resistivity does not depend on area. Okay, resistance depends on area, resistance depends on resistivity, but resistivity does not depend. It only increases with the temperature. So as you increase the temperature, resistivity will increase. Okay, now let's move on to the next question. Question number 38. N identical cells of each EMF E and internal resistance R are connected in series. Okay, so how many cells? N cells, all of them are identical, that means same EMF is same. Value is given here, E capital E, and internal resistance are also given, capital R, are connected in series, and external resistance capital R is connected in series with this combination. The current through this resistance R is, so what we have n number of cells, okay, connected in series, and an external resistance capital R connected with this system. Okay, so each of them has E, R, E, this one is R, sorry, E, R, so on. So what is the net? If you add them, they are connected in series, that means the total EMF will be N into E. And what is the total resistance? Total resistance will be R plus N into small r, right? So this is the total resistance. Resistances will be all in series. So now n number of small r in series will give you NR. Now there is an external resistance capital R, so total resistance of the system will be R plus NR, and the total EMF of the system will be N into E. So definitely it will be N into E divided by R plus NR. That is option A is the correct answer. Okay, now question number 39. If the terminals of a cell are connected to an external resistance, okay, then the potential difference across the terminal is more than EMF of the cell, less than EMF of the cell, equal to EMF of the cell, equal to potential drop across the internal resistance. Okay, so when you connect a cell across an external resistance, okay, what happens is that the terminal value, terminal voltage, terminal potential, this is R, okay, this is called terminal voltage. This is called terminal voltage. The terminal voltage is always less than that of E. If there is an external resistance which is carrying some current, so there will be some potential drop across this internal resistance. Because of this small potential drop, the terminal voltage will always be less than that of the cell. Okay, In case if you can stop the flow of the current, okay, that means you remove the resistor and then you measure the potential, then you will get the exactly the EMF of the cell. There is a different way of doing it, but that is not part of your syllabus. Kirchhoff's first law, that is sum of I equals to 0 at a junction, also known as junction rule or KCL, Kirchhoff's current law, deals with the conservation of. So delta I or sum of I equals to 0 is basically conservation of charges. So Kirchhoff's first law is conservation of charges. Kirchhoff's second law is basically conservation of energy. Okay, so for Kirchhoff's first law, where you are saying that all the currents entering a junction is equal to all the current exiting the junction, that means it's basically saying all the charges that is entering the junction, same number of charges should exit the junction as well. So this is a type of conservation of charge only. Now, if in the experiment of Wheatstone bridge the positions of the cell and galvanometer are interchanged, then the balance point will change, remain unchanged, depend on internal resistance of the cell, resistance of the galvanometer, none of this. So basically, if you see the circuit for Wheatstone bridge, you might have noticed like this, right? Okay, so there is a galvanometer here, and so what will happen if you exchange this cell and this galvanometer? This is a balanced condition. The galvanometer is already in balanced condition, so P by Q is equal to R by S. Now if you swap this thing, that means now the galvanometer is connected. What is the meaning of the swap? Swap means you have connected the galvanometer like this. Now so the galvanometer is connected like this and the electric cell is now connected like this. Okay, so now what will happen to the balance condition? Will it change or it will remain same? Let's see. First, we know that first case, what was the first case condition? P by Q is equal to R by S. Right, that was the first condition. Now, what should be the second condition? Second condition should be Q by S should be equals to P by R. Right, so second, if there it is still imbalanced, it should be Q by S equals to P by R. Now can we prove this from this equation? So let's see. So this Q goes up, this R comes down. So we just exchange these two quantities and we will see that this is P by R equals to Q by S. Right, so this is the condition that we needed for new balanced. This is the new condition for balanced, and that is satisfied only if this was still balanced in the first case. So a balanced Wheatstone bridge will remain balanced no matter how you connect the galvanometer or the cell. Okay, even if you swap it, it will still remain in balanced condition. So it will remain unchanged. Okay, the galvanometer will still be under balanced condition. Now, column 1 gives the certain physical terms associated with the flow of current through a metallic conductor. Column 2 gives the some mathematical relations involving the electrical quantities. Match the column 1 and column 2 with appropriate relations. Again, this is a hot question because as I said, this is not super easy. So first we will see what all we know. Then based on that, what all we don't know, we will try to guess or I will try to understand them. Okay, so first of all, relaxation time, I don't know the relation, what to do. Drift velocity, I see drift velocity here, but this is nothing related to drift velocity either, so I will skip it for now. Now current density, what is current density? Current density is basically J, and J is basically sigma E. Can I find any relationship like that? I can find E by J, but nothing related to J here. But what else we know? We know that J is basically I by A. What is I? I is NEA VD, and divided by A means this is NE VD. So definitely I can see that current density I am getting a match. So option A is match for current density. right? There is one match. Next is electrical resistivity. So electrical resistivity, we have solved one similar question. So as I said, this one is conductivity, this one conductivity means I can find the resistivity. So how to do that? First of all, we will find the conductivity. Conductivity is J by E, and resistivity is given by 1 by sigma, that is E by J. Okay, so E by J must be the second match. So electrical resistivity is option B. Okay, so now we have found the match for A and B. We didn't find any match for C and D. Now we have to see whatever possible can be the value of drift velocity, whatever can be the relaxation time. If we don't know, we have to check the options directly, and if we say this will be 1, this will be 2, this will be 3, and this will be 4. So we know that 2 is matching with 3 is matching with A, 4 is matching with B. Let's check if we can find any match similar to this. So 4 is matching with B, so there is only one match. 4 is matching with B. And if you verify, 3 is matching with A, so 3 is also matching with A. So this combination has one unique answer. So even if we do not know the exact expression for relaxation time, maybe we do not know the exact expression for drift velocity, we can still answer that drift velocity is this one, relaxation time is related to tau. So we can still find this. One more thing, is it? Okay, so even if we don't know, no, sorry, my mistake. So that's why I'm thinking. So relaxation time itself is tau. So relaxation time tau cannot be related to relaxation time tau itself. So this must be the match. So drift velocity is this and relaxation time is this. So even if you forgot the exact relationship, even if you don't remember the relationship, you can first try to understand whatever you know, and based on that try to find the answer. In case you don't know, then you have to think a different strategy. Okay, but most of the cases, 99% of the cases, this strategy should work. Statement based question, another. When a wire is not connected to a battery, then no current flows. Statement 2. In the absence of electric field, free electrons moves randomly or does not move in particular direction. So first they have said wire is not connected to a battery, that means there is no electric field, so no current flows, and no electric field means no current flows, and that is because electrons are moving in the random direction or the mean speed is 0. So both statements are correct and are true, and the statement 2 is the correct explanation. So definitely option A is correct in this case. Now question number 44. Which of the following is different from others? Volt square per ohm, ampere square into ohm, volt into ampere, joule per second square. So how do we know which one to consider? First we will try to figure out the formulas. So what is the meaning of volt square per ohm? Volt square per ohm means V square by R. Okay, V square by R. Ampere square into ohm means I square into R, and volt ampere means VI. Okay, anything looks familiar? They are all the expression for power. They are all expression for power consumed in an electric circuit. Joules per second square is nothing. Joule per second, by the way, joule per second would have been the unit of power, but here they have given joule per second square. So obviously this is easy to guess because all of them are given maybe volt, ampere, volt. Even if you randomly try this question, you might get this question answer correctly, but in the exam, suppose they have given this joule per second and ampere was given, say, ampere square here, then that would have been difficult. You think, okay, all of them are related to current and this one is for mechanical energy, so this must be the wrong answer. May not be the case. In this case, yes. In this case, yes, this is incorrect, but final exam they might change the same question, because obviously exact same question you cannot expect in the board. They will change the options, they will refine the question better. So definitely you can expect the similar question in your board with a more refined options. Question number 45. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statements are correct? So drift speed of electron is constant. Drift speed of electron increases while the moving from A to B. So current is moving from A to B. Okay, drift speed of electron decreases while moving from A to B. The drift speed of the electron varies randomly. So obviously option D is just a random option, that can be correct. So how can we find it? So what is the area? If you can see, the area of A is definitely, area of A is smaller than that of the area of B. Now what else is given? A steady current is flowing. Steady current flowing means I equals to N E A VD A, okay, NEA VD, right? That is the expression. E is the charge of an electron. So this is for A, IA. Now A and IB both are same, so we can say that the same formula, NEB VD B. So here I have used the fact that area for B is B, area for A is A. So if you do all the mathematics, you will know that this is like a continuity equation you have learned in your first PU for flow of liquid or flow of fluid. Same thing is like that. So area into drift speed is constant. Area into drift speed is constant. So if area is less, drift speed is more. If area is more, drift speed is less. So drift speed is basically, you can say that drift speed is inversely proportional to area. Higher the area, lower is drift speed. Lower the area, higher is the drift speed. So in this case, as you can see that current is moving from A to B, so drift speed decreases as it moving from A to B. So drift speed of electron decreases as it moving from A to B, right? Now, when the magnetic compass needle is carried nearby to a straight wire carrying current, then the straight wire cause a noticeable deflection in the compass needle, right? So when you carry a compass needle near to a current carrying wire, okay, current carrying wire is basically producing a magnetic field. That magnetic field will definitely deflect the current carrying the magnetic needle, right? The alignment of the needle is tangential to an imaginary circle with straight wire as its center and has a plane perpendicular to the wire. Okay, so if you see that the alignment of the needle will be definitely on the plane perpendicular to the conductor, and it will be always tangential to a circle, right? That is because the electric magnetic field lines are circular. So both statements are correct. Both 1 and 2 are correct. 47. If a current is flowing in a straight wire parallel to positive x-axis and magnetic field is along the negative positive y-axis. Okay, current is flowing in a straight wire parallel to positive x-axis. So electric field is current is positive x-axis and a magnetic field is along y-axis. Okay, then the wire experiences a force. So why the wire will experience the force? The wire will experience the force because either you can use the old class 10th formula for what should I say, Fleming's left hand rule, or you can apply Lorentz force, where you can have to say that current is basically a charge moving in a particular direction. So either you can use V cross B, which in my opinion is easier. So V cross B is basically giving you an axis on this direction, or if you want to use the old formula that current is in this direction, magnetic field is in this direction, then the force will act along the direction of thumb. So that is also possible. Left hand rule is basically a cross product rule. Okay, so that is why sometimes we use left hand rule for cross products. So this is the rule you can use. Now So basically thumb represents the positive z axis. This is the positive z axis. The outward axis here is positive z axis. There is another way to show that. So you can draw x here, y here, okay, then this will be z, okay. So B is basically along the y-axis, x is the direction of charge. So x cross y is z. So it will be experiencing a force in the positive z direction. Positive z direction. Okay, that is the answer for this question. A strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, remains stationary, moves perpendicular to the direction of the field, moves opposite to the direction of the field. So magnetic field does not affect a stationary electron. Okay, so the electron will remain stationary because there is no force unless and until it is moving, then it is called Lorentz force. Otherwise there is no force on a stationary electron due to magnetic field. Due to electric field there will be a force. The frequency of rotation of a charged particle in an uniform magnetic field is independent of velocity of the particle, charge of the particle, mass of the particle, strength of the magnetic field. Let's see. So what is the when a particle rotating in an magnetic field, what is the force acting on it? Force basically acting on it is given by Q V B. Okay, and that force should be equals to mv square by r. We all know this, right? So this is where we can find the velocity selector. Velocity, one of the velocities will be cancelled. So v equals to qb r by m. This is the velocity, right? Now this is linear velocity. What is angular velocity? Okay, so angular v is equal to r omega. We know that v equals to r omega. So that r omega equals to qb into r divided by m, right? So omega is basically qb by m. This is the angular velocity. Now they have asked you about the frequency. So omega is basically 2 pi f. That is, f is frequency. That is qb by m. So frequency is qb by 2 pi m. Okay, so this is the frequency. Now if this is the frequency, as we can see, it depends on charge, it depends on magnetic field, it depends on mass as well. Okay, so it does not depend on the velocity of the particle. So frequency is independent of the velocity of the particle. It depends on the charge, it depends on mass, it depends on the strength. So option A is the correct answer. The radius of the circle described by a charged particle moving perpendicular to the uniform magnetic field depends on its mass only, its velocity only, both mass and velocity, neither mass nor velocity. So the radius of the circle, that means we have already found the fact that velocity is given by this. So from here we can calculate the radius. So radius is basically qb by mv. Okay, so this is the radius of the circle. Now what they have given, so it depends on its mass, it depends on its velocity. Okay, it depends on both mass and velocity. Okay, so it depends on both mass and velocity along with the charge and the magnetic field. So both mass and velocity is the answer for this question. Now, a long straight wire carrying a current induced magnetic induction at any place that is proportional to the distance from the wire independent of distance. Inversely proportional to the distance from the wire, inversely proportional to the square of the distance from the wire. So, long straight wire, a current induced in magnetic induction at any point is. So what they are saying that what will be the magnetic field at this point, that's it. Okay, the language may be difficult, but it is basically they are saying what is the magnetic field. So magnetic field is inversely proportional to the distance for a long straight wire. We have done the derivation. If you are interested, you can do the derivation as well. So it is inversely proportional to the distance from the wire. Okay, be careful, it is not inversely proportional to the square of the distance, it is inversely proportional to the distance. an electron is projected with an uniform velocity along x-axis of a current carrying long solenoid. Which of the following is true? So we have a current carrying long solenoid, okay, and an electron is projected along the axis of the solenoid. The electron will be accelerated along the x-axis. The electron path will be circular about the axis. The electron will experiences a force 45 degree to the axis and hence execute a helical path. The electron will continue to move with the uniform velocity along the axis of the solenoid. Very interesting question. So most of you might be tempting on answer ABC. Actually correct answer is option D, because the magnetic field inside the solenoid, okay, either it will be parallel, okay, with the direction. So electron is moving in this direction, and magnetic field inside the solenoid is basically a constant value, right? So magnetic field will either be parallel or it will be anti-parallel, because the direction of current is not given. Okay, so either magnetic field will be parallel or it will be anti-parallel. Now what is the force? Force we know that is equal to QVB sin theta, right? V cross B, so sin theta. So if they are parallel, that means theta is 0. So theta 0 means sin theta 0. Sin 0, that means force will be 0. Similarly, theta anti-parallel means theta is 180 degrees. Again 180 degree means sin theta 0. Sin theta 0 means again it will be 0. So no force will act. That means the charge will continue with the move in the uniform velocity along the same direction. Okay, so don't get excited. It will not create any helical motion. It will not create any circular motion. It will only continue to move in a straight path. Now, the beams of electrons and protons move parallel to each other in their same direction. Then they attract each other, repel each other. No relation, neither attract nor repel. So electrons are moving in this direction. A proton is also moving in this direction. So this is, suppose this is electron, this is proton. Okay, now how to answer this question? To answer this question, we have to borrow another concept, that if we have two parallel current carrying wire carrying current in the same direction, they tend to attract each other, and if the same parallel wire carrying current in the opposite direction, then they repel each other. You can use the direction of magnetic field as well, but this way it will be easier to remember. Okay, this is the easiest way to remember. You can find the magnetic field due to the moving electron, then find the magnetic field due to moving proton, then you can find the interaction between them. That will take a long time. Now if you consider the electron is moving in this direction, what will be the direction of corresponding current? So electron moving in this direction means the corresponding current can be given in the opposite direction, right? So current basically flows in the opposite direction of the electron motion, whereas in case of proton, the current will flow in the same direction of proton, right? Because it's a positive charge, so positive charge represents the current, negative charge opposite to the negative charge represents the current. Now basically what is the meaning of that? The meaning of that, we can consider them to be consisting of two current carrying wires having current in the opposite direction. So opposite direction current means they will repel each other. So they will repel each other. So even though proton and electron, they have a magnetic attractive properties, but when they are moving, they will repel each other. Very interesting, right? A rectangular coil carrying current is placed in a non-uniform magnetic field. On the coil, the total force is non-zero, force is 0, torque is 0, none of this. So obviously, if you keep a current carrying wire in a magnetic field, it will experience a torque. So torque cannot be 0, be it uniform or non-uniform. But in case of non-uniform, the force will not be 0. It will still experience as a force. So in this case, only force is non-zero is the correct answer. If the field is uniform, force will be 0. Torque will not be 0 in any case. Okay, because it's a non-uniform, so force is not 0. Now let's look into question number 55. A conducting circular loop of radius r carries a constant current I. It is placed in an uniform magnetic field B such that B is perpendicular to the plane of the loop. The magnetic force acting on the loop is. So first of all, you have to understand what is the meaning of this question. We have a circular loop placed in a magnetic field. The magnetic field is either into the paper or out of the paper, that is basically perpendicular to the plane. So for now we are assuming it is into the page of the paper, okay, into the page. So that's why I have denoted it like this. Now current can be clockwise, anti-clockwise. I am taking clockwise current for right now. Now if you consider the magnetic field, the motion, this is the direction of current at this point. So consider a small element dl, okay, and the current say I. Then you can find the force acting on this part by applying the formula force equals to I dl cross B, right? This is the formula. Now you cannot say L cross B because here it is a circular coil, so it will be basically sum of all these forces. Now if you say what is the direction of this force, so we have to understand that the direction of this force is basically this is the dl, and it is basically into the page of the paper. So dl cross, if you do the cross product, it will be along this direction somewhere, okay. So it will be somewhat in this direction. Now there will be a radially opposite component exactly of this dl, okay. If you take a radially opposite, we know what is the meaning of radially opposite. Radially opposite means it is basically on the other side of the radius. Now in this case the force will be exactly same but in the opposite direction. Similarly, you can consider small dls. For all the dls, the respective forces will be cancelled by the opposite half of the circle. So because it's a circular loop, because of symmetry, all the forces acting on this loop will be cancelled and total force acting on this circular loop will be 0. So if the magnetic field is constant and if it's a circular loop, definitely all the forces will be cancelled, so net force acting on this loop will be 0. It is remember that for uniform magnetic field, if you place a circular loop or a rectangular coil, the force will be 0. In case of rectangular coil, there will be a torque acting on it, okay. In case of circular loop, torque will be also there, but torque will also cancel each other. There will be a lot of torques and they will also cancel. So in case of circular loop, torque, force both will be 0. In case of rectangular coil, torque will not be 0 but force will be 0. Now in a moving coil galvanometer, the deflection phi on the scale by a pointer attached to the spring is given by, we know that it is NAB by K into I. So this is the deflection given by NAB by K into I, right? So this is the formula for deflection. Now current sensitivity is basically phi by I, so that is basically NAB by K. If you want to remember, this is also a formula. Now resistance of an ideal voltmeter is, so resistance of an ideal voltmeter, voltmeters are connected in the circuit with parallel combination. That is why ideal voltmeter should have infinite resistance so that it does not draw any current from the circuit. So ideal voltmeter should have infinite resistance, ideal ammeter should have 0 resistance, okay. Be careful, voltmeter and ammeter, they are connected differently. Ammeter is connected in series, so that's why it should be 0 resistance so that it does not increase or decrease the resistance. Similarly, voltmeter is connected across the parallel combination, so any other resistance having other than infinity will eventually change the resistance a little bit. That is why ideal voltmeter should have infinite resistance. Now a charged particle moves in gravity-free space without change in its velocity. Which of the following combination is not possible? So what is the question? A charged particle is moving, okay, without changing its direction, okay. There can be electric field, there can be magnetic field, okay. There can be magnetic field as well, but it is not getting deflected. Not getting deflected means it is not accelerating. First of all, it is moving with constant speed. That means it is not accelerating when it is possible. So first of all, if electric field is not zero, it will always experience a force. Okay, that force is given by F is equal to Q into E. So if electric field is not zero, there will always be an electric force. Magnetic force can be there, cannot be there, based on the direction of the motion and the direction of magnetic field. Okay, because magnetic force, this is the electric force. Magnetic force is basically a cross product, right? Q V cross B. So magnetic field can be zero, may not be zero, but still the force can be zero. Okay, if the angle between them is 0, okay, or 180 degrees, in that case sine theta is 0. So that is why magnetic force still can be 0 without B being 0. Very important part to understand, that B may not be 0. Okay, but the force can be 0. But in case of electric field, because it is getting multiplied by a scalar quantity, if there is a non-zero electric field, there has to be a force acting on this charge, right? So basically electric field is not zero and magnetic field is zero is not possible if it is moving. Okay, now you will say, sir, here also electric field is not zero, but magnetic field is also not zero. That means what? In this case, in the option D, what is happening? The electric force is getting balanced by the magnetic force. That is possible, right? So they can balance each other. Okay, they are acting in the opposite direction, so that the electric field and magnetic field are oriented such a way that this quantity and this quantity are cancelling each other. So that is quite possible. But only electric field is not zero, but magnetic field is zero is not possible, because in this case the charge will by default will get some force acting on it. Okay, electric field is zero, magnetic field is not zero, obviously possible, as I mentioned that electric field zero means no electric force acting on it. Magnetic force such a way that V cross B is basically zero, that is why it is possible, but this is not possible. So correct answer is option B for this question. Very tricky question, but you have to understand it fundamentally, why E not equals to 0 is not possible, but B not equal to 0 is possible. Now, a positive charge is moving in combined gravitational and magnetic field. The charge moves without any change in its velocity. If the velocity of the charge is along the east, then the direction of magnetic field is along. So first of all, suppose this is a charge. Okay, what are all the forces acting on it? If nothing is there, so the mg is acting. Right, mg is acting. So by default the charge will, if you throw a charge like this, it will falling like this, slowly it will touch the ground, right? It will be a parabolic motion because gravitational force is acting downward, but it says that it is moving in the same level. Okay, it is moving without any change in velocity. Without any change in velocity means it is moving in the same direction. Velocity includes magnitude and direction. That means the charge is moving in the same direction. How it is possible? It is possible if the magnetic force FB is basically balancing it. If the magnetic force FB is balancing it, then only it is possible. Now you don't have to find the magnitude of the magnetic field. What you have to find? You have to find the direction of magnetic field. Okay, so object is moving in this direction. Now what should be the direction of the magnetic field such that you get this in the upward direction? Now the charge is moving in the east, right? So charge is moving in the east direction. Okay, and this is downward direction, this is upward direction, this is east, this is west. Okay, and there will be a north and south as well. This will be north, this will be south. This is into the paper. North is into the paper, south is out of the paper. Okay, so be careful, because we are considering north, south, east, west, and we have up and down as well. Okay, so that is why it is a it is not only based on the east, west, north, south that we are familiar with. So north, east, south, west, we generally draw it like this on the flat paper. which points the direction. In that case, we ignore the up and down directions, right? So here we are also considering up and down direction. That is why this is a tricky question. So as you know that if we do V cross B, we should get the magnetic force. So how to find the cross product? You start with the first vector, pointing your fingers in the direction of the first vector, then you slowly curl your fingers towards the second vector, and whatever is your direction of your thumb, that will be the direction of the resultant vector, right? And if you are not able to curl in this side, then you have to rotate your hand and you have to curl in the direction of the second vector. Always the fingers will be curled in the direction of the second vector, and based on which direction you are bending, okay, maybe this side or that side, the direction of the magnetic force can be determined. So in this case, it must be acting in the north direction, so that the force is in the upward direction, right? So it will be in the north direction. Okay, now next question. Charge Q, mass M, is moving in uniform circular motion under the action of a magnetic field B. If the radius of the circle is R, then the magnetic moment associated with the charge is given by. This is a little tricky, complicated question, but I have seen this question in your question bank, that's why I have included it. So how to solve this question? You have to, after solving it, if you remember the result, very good, or if you want to understand what is happening here, that is very good as well. So we have a charge moving in a circular path. Okay, the charge Q say moving in a circular path. Okay, so what is the magnetic moment? So first of all, magnetic moment, what is the definition of magnetic moment? Definition of magnetic moment is I into area. Okay, I into area. Now what is the I in this case? And then what is other things that is acting on this? So we know that centripetal force must be acting on the charge. Okay, centripetal force obviously acting, so radius say R. Then what is the force? Magnetic force. Magnetic force is basically the same direction as centripetal force, and it is basically providing the centripetal force. So these are all known. QVB equals to mv square by R. Right, these are all known fact. Okay, if you see all the expression, there is no V given here. Okay, all the expression is no V given here. So first of all, you have to find V. If you remember, it's very good. Otherwise, you can find it like the way I am doing it. So this V cancels. There is a one single V. So you have to do the cross product QBR by M. This is the expression for velocity. Now we have to find the current first. Okay, area is easy. Area is this area. So area is basically pi r square, right? So area part is easy. We have to find the current. What is the current? So what is the velocity? Velocity is V, and how much time it is taking to cover the entire part. Okay, so in say it is rotating with the speed V, right? So what is the current because of this charge V? That is very important to find. So what is current? Current is basically Q by T. Okay, Q by T is the current. Now you cannot have anything other than that, but what we will do, we will multiply the circumference of this circle. Circumference of this circle in top and bottom. So what is the circumference of the circle? Circumference of the circle is 2 pi r. So Q by 2 pi r into 2 pi r by T. Okay, now what is 2 pi r by T? So this part we cannot calculate, but this part we can calculate. 2 pi r by T means the distance traveled and divided by the time. So distance traveled divided by the time will give you the linear velocity. In this case, linear velocity. If you just using 2 pi by T, that will be angular velocity. Again, you have to convert it. So but we will not bother that. This is the distance traveled. This is the time taken for one complete loop. This is the time taken. This is the distance traveled in one complete loop. So this is basically the velocity. So that is basically, current is basically Q by 2 pi r. As I said, this is little tricky. Okay, not simple. So this is the current. So let's put these values over here. So Q by 2 pi r into V into area is pi r square. Okay, pi cancels, one of the r cancels, so you get qvr by 2. This is one of the expression. This is common problem, but in your question bank they have gone one level higher. Okay. So here you have to replace this v with this term. Okay, so q r by 2 into v. So what is the value of v? qbr by m. So you get q square b r square by 2m. Okay, so q square b r square by 2m. So this is the answer. And if you are preparing for KCET, this is a very good candidate question for KCET as well. Okay, this level of question might come in your KCET exam as well. Very good question. Okay, completely brand new question I have seen. This is common. This part is common. This part is common in your previous year questions. But this is something whatever I have seen is something new. So be prepared if you are preparing for KCET exam as well. You can remember the value q square b r square by 2m, or you have to do this derivation. So this is a little longer question. Now let's move on to the next question. This is an easy question, so we have solved one difficult question. Now let's move some easy questions. A current carrying wire is placed parallel to the magnetic field. The force due to the magnetic field is 0. The net charge on the current wire is 0. Okay, now we have a current carrying wire. Okay, and it is said that the current carrying wire is basically parallel to the magnetic field. So current carrying wire is carrying current in the parallel direction of the magnetic field. Okay, now it says that the force acting due to the magnetic field is 0. So what is the formula for force? Force is basically BIL sine theta. Now here the force is 0 because this theta is 0. Because magnetic field, say this is north, this is south, magnetic field is basically parallel to the current carrying current. So this is the current that is being carried. So because the magnetic field and the current carrying directions are parallel, force is 0, and that is because this theta is 0. The net charge has nothing to do with it. Yes, the net charge on a current carrying wire is 0. That is also a fact, but this is not the reason. Okay, so both statements are true, but statement 2 is not the correct explanation of the statement 1. Okay, so option B is correct for this question. Very, very careful. Even though both statements are correct, it is very confusing sometimes. Both statements are correct. Student often answer option A because both statements are correct. But both statement can be correct, but whether it is actual reason for the statement 1 or not, that is you have to determine. So here, because current is not 0, right? So it is basically current carrying wire, force acting on a current carrying wire is BIL, okay, sine theta. So from there it is coming to be 0. Now match the following: the physical quantities for a column 1 with column 2. So again, as I said, you don't know anything, you don't know any of the matching. How can you answer such questions? So first of all, what is the quantities given? Current sensitivity, then intensity of magnetic field, magnetic dipole moment. Okay, now I know that current sensitivity is based on the measurement of galvanometer, so it is related to divisions. So only one unit with divisions, that is division per ampere. So definitely this is the current sensitivity. So I know 1 is matching with C, right? So 1 is matching with C. Now what else? We know that magnetic dipole moment is basically I into A. Right, I into A. So that is again it is ampere meter square. Ampere is the unit for current, area's unit is meter square. So ampere meter square is the unit for magnetic dipole moment, that is ampere meter square. So it is option B. Now automatically you will get the other matching, that is A. Okay, try to match 1 or 2 in case you see any doubt. For example, here you see that 1 is matching with C is given in 2 options. Okay, so definitely you can guess that obviously I have to check the second level as well. If you see only one of the matching option is with 1 C, then definitely you can mark that as correct. You don't need to think twice about it. So 2 is A, 3 is B, right? So this is the correct matching, option B. Now, next question, another matching question. The physical quantities here, the physical quantities are given: magnetic field, magnetic permeability, magnetic moment. Okay, now all of them are complicated terms. Okay, but magnetic moment I know. Magnetic moment, again, what is magnetic moment? Current into meter square, right? So we have seen that magnetic moment is basically current into area. Current's unit is ampere and area's unit is meter square. So basically this is the unit for magnetic moment. So its dimension will be A into L square, right, or L square, because L comes first, L square into A. Okay, so this is the dimension for magnetic moment. So magnetic moment, we will know that this is basically matching with B, right? So this is the easier one, we have found it. Now which one is magnetic field, which one is magnetic permeability? Now I am showing you a trick which 99% will work, but there is a chance that 1% this will not work. Okay, what is that? So we have found one of them correctly. Now we are left with two, right? So definitely the whatever is given straight generally does not have a match. That is a trick that I am going to teach you, but this works most of the cases. For longer match the following, it is not work always. Okay, so be careful. This is a trick with some caution, obviously. So generally if it is not matching with this, then definitely it is match with C. So it will match with C. And magnetic permeability, again cross matching. So this is called the cross matching criteria. Generally teachers don't give options where you can directly match. Okay, but some cases it will backfire. So be careful. If you don't know what other method you can use, you have seen that for sure that third is matching with B. So if you see all the matching, third is matching with B in only one case. So definitely this is the answer. You can answer it, but in some cases, suppose third is matching with B in two cases, then how can you answer it? So generally always remember, this is a cross matching. If you have found one of them correctly, the others generally in a crossed fashion. Okay, so that is 99% of the cases it will work. But if the matching is given for 4 matching or 5 matches, then definitely it will not work. But in your board exam, maximum matching will come up to 3, because in the standard your model paper also the matching was given up to 3 only, but in the question bank they have given up to 5 matching. So in that case 5 matching, this will not work. Okay, so but as I said, you matched one of them, you first check whether this is any of them is actually getting this match or not. So you saw that, okay, third is matching with B in only one case. So definitely this will be the matching, that is the correct answer we are looking for, right? Now a charge, another matching question here, angle theta. Okay, this is a slightly different. A charged particle of charge q is moving in a uniform magnetic field. The angle between the velocity v of the charged particle and magnetic field b is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing the appropriate trajectory traced by the charged particle for different possible values of angle theta. Okay, so theta 0, 45, 90, circle, straight line, helix. Okay, so we definitely know that for angle theta 0, this is a straight line, so 1 is matching with B, and for 90 degrees it is a circle. So these two are known. Obviously third one will be also known because it's a three-way fight. So theta is 90 for circle, so this is A. So definitely this must be helix. Okay, so this must be helix. So as I said, let's see the match. So here we have 1 with B in 2 cases, 1 with B in 2 cases, right, and 2 with C. 2 with C is only 1 case. So obviously option B is the correct answer. So once you have completed the matching like this, the way I am showing you, you have to check the correct answer and then you can find the correct match. Next question. A charged particle is released from the rest at a region of uniform magnetic field and the electric field parallel to each other. Okay, the particle will move in a helix, circle, straight line, cycloid. So there is a magnetic field, there is an electric field. Okay, let me use different color. there is a magnetic field, there is an electric field. Okay, magnetic field is given by yellow line, electric field is given by white line. Okay, so this is the electric field, this is the magnetic field. Now you have a charge particle, you have a charge particle, say here, so you released it from rest. Okay, initial speed is 0, then what will happen to this charge particle? What will be the motion of this charge particle? Released means just dropping it. So as I said in the past also, as soon as you release it in this vicinity, it will start experiencing the electric force. It will start experiencing the electric force, because electric force is basically Q into E. Okay, so as long as it has some charge, it will start experiencing the electric force. So electric force will make it move either in the direction of electric field or in the opposite direction of the electric field based on the polarity of the charge. If it is positive charge, it will move in the direction of electric field. If it is a negative charge, it will move opposite direction of the electric field. Now what else is given? Another thing that is given is the magnetic field is parallel to the electric field. So magnetic field is parallel to the electric field means even if it will move with the velocity say v after some time, the magnetic field will be 0, because sine theta is either 0 or sine theta is 180 degree. In both cases, q, b, v, sine theta, theta is 0 or theta is 180 degree. So the charge will not experience any magnetic field. Okay, for it to be experiencing magnetic field, the electric field and magnetic field should not be parallel. Okay, it should not be parallel. Because they are parallel, it definitely will be a straight line. So the path will be a straight line. It will move along the electric field. Okay. Now, universal property among all substances: diamagnetism, paramagnetism, ferromagnetism, non-magnetism. So the universal property is diamagnetism. Okay, some objects show diamagnetism, they are diamagnets. If they have a stronger property which is covering the diamagnetism, that is called that it can be a paramagnet, it can be a ferromagnet, based on which one is the dominating one. Next, when the angle between the magnetic moment of the small compass needle and the uniform magnetic field in which it is placed is theta equals to 180 degree. The torque on the needle is maximum, the needle is stable equilibrium, the potential energy of the needle is 0, the needle is in unstable equilibrium. So we have a magnetic field. Let us understand the question first. So we have a magnetic field B now, and we have a needle. We have a magnetic needle which is placed opposite direction of the magnetic field. So if it is in the same direction of the magnetic field, it is called in a stable equilibrium. Okay, no torque is acting on it, so torque is 0. Okay, why torque is 0? Torque is basically mb sine theta. So if theta is 0, torque will be 0. Okay, if theta is 180 degree, then also torque will be 0. But in this case, if slight displacement from its position, it will displace the magnetic needle. So that is why it is called unstable equilibrium. Okay, so it is a needle is in unstable equilibrium. For theta equals to 0, stable equilibrium. For theta equals to 180 degree, it is unstable equilibrium. Now, a magnetized needle placed in a non-uniform magnetic field in general experiences both force and a torque. So, same as dipoles. Okay, magnetic needle are basically considered to be magnetic dipoles. They are called magnetic dipoles. So, magnetic dipoles, like dipoles, if you place it in a non-uniform electric field, dipole experiences force as well as torque. Similar to that, here also the magnetic needle will experience a force as well as a torque. Now 69, the dimension formula for magnetic intensity or magnetization, also unit. So what is magnetization? Magnetic intensity is H, magnetization is M. Okay, both of them has the same dimension, same unit. Now how can we find or how can we remember what is the unit for H or M? Okay, both of them has same unit, same dimension. Okay, so what you have to remember is that the dimension is given by, so first of all, H and M both has the same unit, and its relationship with magnetic field in general is given by mu naught H plus M. Okay, this is the basic relationship. Generally there is another quantity involved, mu. You generally write it in terms of mu because in free space there is no meaning of magnetization and magnetic intensity, but assume that this is the formula. Okay, now how can I find the dimension from this? So to find the dimension, you can use the dimension of B, you can find the dimension of mu naught and find the corresponding dimension of H as well. But we are smart, we will not go into that path. We know that magnetic field inside a solenoid is given by mu naught N into I. Okay, this one we know. So basically what we will do, we will say, okay, both of the quantities are same, so let me write it in only what we have asked to find. We have asked to find intensity in this case, so we will keep it only H, assuming m is equal to 0, because dimensionally that does not matter, because both of them have same dimension. So and we will equate it with the known equation, that is mu naught I. So in this case mu naught cancels, so magnetic intensity is N into I. Now what is N? N is basically number of turns per unit length, so its dimension is L to the power minus 1, number of turns per unit length. And what is I? I is current, so its dimension is A. So dimension of magnetic intensity or magnetization is basically L inverse A, or its unit is ampere per meter. Its unit is ampere per meter. So sometimes they might ask you the same question with the unit or the dimension, and it can come for magnetic intensity or magnetization, both are same. Okay, but don't confuse it with the magnetic moment. Magnetic moment is different. Okay, magnetic moment is ampere meter square, whereas magnetization is ampere per meter. Okay, so I know it is confusing, lot of similar terms, but you have to understand and remember them. Next question 70. If the magnetic susceptibility of a material is 100, then its relative permeability. Now relative permeability and magnetic susceptibility are related, that is 1 plus magnetic chi. Okay, the spelling is CHI and we say chi. Okay, now magnetic susceptibility is given 100, so it, relative permeability will be 101. Okay, for which one of the following substances the magnetic susceptibility is low and negative? So only one substance which has the negative term associated with it, that is diamagnet. Okay, so if you see which one of them are diamagnet, only bismuth is a diamagnet, whereas oxygen is a paramagnetic. You may have learned it in chemistry that oxygen is a paramagnetic gas. So oxygen is paramagnetic, iron is paramagnetic, iron is ferromagnetic, in other words sodium is paramagnetic. Sodium, oxygen are paramagnetic, iron is ferromagnetic, and bismuth is diamagnetic. Okay, now let's see another matching. Okay, with the following column, what are the terms? Diamagnetic substances, paramagnetic substances, and ferromagnetic substances. Okay, so let's see the options. Options are given. Mu is less than mu naught, domain formation chi m greater than 1. Okay, so domain formation happens for ferromagnetic substances. Okay, domain formation is only possible for ferromagnetic substances, so definitely C is matching with Q. Now as I said, first rule of check, we have to check which of them is basically matching. C is Q on option B and option D. So definitely first check, we cannot answer this question with this matching only. Okay, so C is with Q, C is with Q. So two of the possible answers. Okay, now as I said, the second part is that it generally does not match directly. So this will not match with P. Okay, this will match with this one. Okay, so diamagnetic substances chi m is greater than 1, but I don't think that is a good option. Okay, for diamagnetic substance chi m is less than 1. So the option I told you generally does not work always. So this is a proof that in this case the crisscross matching is not working. Okay, so diamagnetic substances basically matching with P, direct matching, and paramagnetic substances matching with R. Okay, so A is matching with P, B is matching with R, and C is matching with Q. So option B is the answer. So as I said, generally it works, but sometimes this is a special case where it does not work. So as I said, but if you start with this point, it is matching cross, okay, but obviously it can match with that as well. So definitely you cannot always rely on that technique that I showed you, but it will work in most of the cases. Some particular cases, it is an easy question. We know that for diamagnetic substances, chi-m is less than 1. Okay, and mu is basically less than mu naught. Okay, that is why relative permeability is negative, considered negative, right? So that is why it is the correct answer. Next question: the atoms in which not relative permeability, susceptibility is negative, relative permeability is less than 1. The atoms in which of the magnetic materials have permanent magnetic dipole moment? Only diamagnetic material, only ferromagnetic material, only ferromagnetic substances, both para and ferromagnetic substances. Only ferromagnetic substances has permanent dipole moment, permanent magnetic dipole moment. Paramagnetic also have dipole moment, but they are oriented in a different direction. So okay. So this question will be both atoms and both para and ferromagnetic substances have permanent dipole moment. Okay, because atomic level, paramagnetic substance also have a dipole moment. That is why they are called paramagnetic substance, right? If you see, in case of oxygen, there is a lone single electron, so that is basically giving you the paramagnetism of the oxygen. So that is why both para and ferromagnetic substances have permanent dipole moment. In case of ferromagnetism, permanent dipoles are doing a conference in a particular area. That area is called domains. All the domains in the entire paramagnet, they have different alignment. That is why they are normally they don't behave like a magnet, but if you can align all the domains, then they behave like a magnet, right? So in case of ferromagnetic also, don't get confused. Ferromagnetic definitely have dipole moment atomic level, and they generally align it in a material level. So both para and ferromagnets, they have permanent dipole moment. Which magnetic property is responsible for strong attraction by magnetic field? Paramagnetism, diamagnetism, ferromagnetism, both para and ferromagnetism. So we know that strong attraction happens only in case of ferromagnets. So basically ferromagnetism is the reason behind strong attraction. If a magnetic substance is kept in a magnetic field, then which of the following substances moves out of the magnetic field? Okay, semiconductors, paramagnetic substance, ferromagnetic substance, superconductors. Now, if you studied your NCERT book thoroughly, then you know that superconductors are basically perfect diamagnet, okay, and they get repelled by a magnetic field. Okay, so superconductors or diamagnets, you might find the option as a diamagnet as well. So diamagnets, superconductors are obviously diamagnetic. Okay, so either diamagnetic or superconductors, both are same. So they will be getting repelled out of the magnetic field. The ratio between magnetization and magnetic intensity is called permeability, is called relative permeability, it is a dimensionless quantity, it is a reciprocal of susceptibility. Okay, so let's see the ratio between magnetization and magnetic intensity. So magnetization is M, magnetic susceptibility is H, and that is basically chi. Okay, that is the definition of chi, that is called magnetic susceptibility. Okay, so this is how good it is getting magnetized, and it is how it what is the inside field. So that is called magnetic susceptibility. It is a dimensionless quantity. Okay, it is not the reciprocal of susceptibility, it itself is susceptibility. So the correct answer in this case is it is a dimensionless quantity, it has no dimension. Okay, so it is a dimensionless quantity. A compass needle of magnetic moment m, small m, is placed in a uniform magnetic field of B such that the angle between them is theta. The ratio magnitude of the torque on the needle to the potential energy of the needle is proportional to sin theta, cos theta, tan theta, sec theta. So what is the formula for torque? Torque is mb sine theta. It is a vector quantity, so vector quantity always accompanies by sine theta. And what is the potential energy? Potential energy is minus mb, so we are ignoring the minus sign as it is said only the magnitude mb cos theta. Okay, it is cos theta. Now they have asked you the ratio of magnitude of the torque by potential energy. So torque by potential energy is basically mb will cancel, it will be sine by cos. So sine by cos means tan theta. Okay, so this answer is tan theta. Now, another interesting question, this question is again taken directly from your NCERT textbook. The following figure shows a small magnetized needle P placed at the point O. So this is a small magnetized needle P placed at point O. Okay, the arrow shows the direction of magnetic moment. Okay, so this is the direction of its magnetic moment. Okay, the other arrows show different positions and orientations of the magnetic moment of the other identical magnetized needle Q. So these are the different locations for magnetic moments Q. Which of the following statement is false for the above configuration? So you have to find the false statement for this given configuration. Okay, so first of all, let's see what are the statements. In configuration PQ1 and PQ2, the system is not in equilibrium. So PQ1 and PQ2, if you see, in both cases they are perpendicular to the existing dipole moment of the magnet, so they are definitely not in equilibrium. Okay, so if you find the potential energy, which is basically PE cos theta, or MB cos theta. So potential energy is MB cos theta minus MB cos theta. Okay, so in this case the angle is 90 degree, that means potential energy is not zero. So potential energy is not zero. Sorry, it is nothing to do with potential energy, it is something to do with the torque, right? Equilibrium. So equilibrium means torque acting on the system is MB sine theta. Okay, and as you can see that equilibrium means no force or torque acting on the system, right? So the torque acting on this system when they are in the 90 degree angle, so in this case they are in the 90 degree angle, so in both cases torque is basically not zero, that is MB. Okay, so torque is equals to MB. So both cases what you will see that the magnetic moment is basically making an angle 90 degrees, so definitely there is no torque there is definitely torque acting on this system. Now so they are not in equilibrium, so this is a correct statement, but we have to find the false statement. The system will be in stable equilibrium for configurations PQ3 and PQ6. So stable equilibrium, let's see, PQ3 and PQ6. Okay, PQ3 and PQ6. Now if you see that they are, in this case they are along the axis. So in the axis case, axial case, you have to remember that in the case of axial case, this is the magnetic moment, so its magnetic field is basically in the same direction on the axis. Remember the dipole one, electric dipole, when you are trying to find the electric field on the axis. So if the dipole moment is along this direction, the electric field is also in the same direction. So that is why they are in the same direction, that means the angle is zero. Angle zero means torque acting on it is zero, so it's a stable equilibrium. Okay, now what about this? This is a rectangular equatorial plane case. Equatorial plane case means if this is the dipole moment, okay, then the resultant magnetic field will be opposite direction. Okay, so if this is the magnetic field, the resultant magnetic field due to this on this area will be in this direction, so both will be obviously in the same direction. So again angle theta 0, angle theta 0 means stable equilibrium. So this is also a correct statement. This is a correct statement, this is a correct statement. The system will be unstable equilibrium for configurations PQ4 and PQ5. So PQ4, obviously they are in the opposite direction, so theta is 180 degree, theta 180 degree means it's an unstable equilibrium. Okay, because if you just rotate it, it will start rotating. Similarly PQ5, again we have found the direction of the magnetic field, in this case in the opposite, so they are again 180 degree configuration. So 180 degree means unstable equilibrium, 0 degree means stable equilibrium. So people get confused with this, the equatorial plane one. So in case of equatorial plane, you have to understand when you're trying to find the magnetic field, okay, it has to be in the opposite direction of the magnetic moment. That's it. Okay, that is you can take help from your electric counterpart, where you have found the direction of electric dipole moment in case of equatorial plane. Okay, so this is also a correct statement. So 3 statements are correct, so definitely the 4th one will be incorrect. PQ6 corresponds to the maximum potential energy state among the given configuration. So they are saying that PQ6 is basically maximum potential energy. Now PQ6, in this case, angle theta is 0. So angle theta is 0 means it will correspond to the minimum potential energy, not maximum. Maximum potential energy when the angle is 180 degree. So maximum will happen only for PQ4 and PQ3. So these two will be maximum potential energy, because potential energy is minus mb cos theta. So if the theta is 180 degree, then minus minus will cancel, so you will get mb. Okay, so in that case, only when the angle is 180 degree you get maximum. In any other case, obviously this is the directly 0 degree, so it will be minimum case. Okay, so obviously answer for this question is option D. Sorry, option D is the correct answer. The SI unit of magnetic flask is Weber per meter, Tesla per meter square, Weber meter square. Okay, so the SI unit of magnetic flask is Weber, okay, or Weber or Tesla meter square. Okay, Weber itself is basically Tesla meter square. Okay, magnetic flask is basically defined by magnetic field into area. Okay, magnetic field's unit is Tesla, area's unit is meter square. So Tesla meter square or Weber, the common name given to this quantity is called Weber. Okay, and obviously these are not correct answer. Statement 1, another statement based question. The net magnetic flux through any closed surface is 0. Yes, net magnetic flux is 0, we know that. This is a correct statement. The number of magnetic field lines leaving the surface is balanced by number of lines entering it. Okay, so this is another statement. So as I said, this is a north pole, south pole. So suppose there is a magnet inside a closed surface. The number of field lines exiting the surface, same number of field lines will always enter the surface. It is always true. Okay, so basically that is why net magnetic flux is 0. So net flux is field lines exiting the surface. Okay, so you can calculate that. So net flux is basically, then you can multiply with the area, but area is immaterial here because field lines exiting the surface, same number of lines is entering, so net flux will always be 0. So both statements are correct, and statement 2 is the correct explanation for 1. So obviously option A is correct in this case. SI unit of magnetic flux. Okay, same question, format is different, we know. This is Weber WB. Okay, not Tesla, not Tesla per meter square, not Weber per meter square, it is Weber. Okay, in electromagnetic induction, the induced EMF in a coil is independent of change in the magnetic flux, the time of change of magnetic flux, the resistance of the circuit, the number of turns in the coil. So what is the electromagnetic induction? Epsilon equals to minus d phi by dt. Okay, phi b, I am writing phi b because to denote it is a magnetic flux. Okay, so change of, not only change of magnetic flux, time of, not only time of number of time, not only time, not only their change, not only time, resistance obviously does not depend, but number of turns. So if there is a more number of turns, we apply n over here. Okay, so definitely it depends on the number of turns. Okay, so very interesting question. You might find what is this question is about. It depends on change, it depends on time. Most of the students casually will answer option A. Okay, so be careful, option A is not correct in this case because it does not depend only on the change on the flux. How fast or how quick it is happening, based on that the EMF depends. Okay, so even if you change the flux, say for example if you take a magnet very slowly towards the coil, the current will be negligibly small because the EMF induced is very small. Okay, but if you do the same thing very fast, you will get a high amount of current. Okay, so it depends on how fast or how slow the current is, flask is changing. But in case of number of turns, if it is a coil, it depends on how many number of turns are there in the coil. For single loop, okay, obviously n equals to 1. For more number of turns, it definitely depends on the number of turns. An EMF induced across the ends of a moving conductor coil in a magnetic field. This is in accordance with Ampere's law, Gauss's law of electrostatics, Gauss's law of magnetism, Faraday's law. So EMF induced on a, since this is plus, this is minus, EMF induced in a moving conductor is basically due to Faraday's law. Don't answer Gauss's law of magnetism by mistake. Okay, now, so this is a question which I was there in your model question paper 1, I guess, but the question was given with multiple correct answers. This is a corrected version of that. If you have seen my model question paper 1, I said in the given options there are 2 correct options, but here we have given you a corrected version, only 1 correct answer is there. So first of all, we have to understand what is happening. Okay, so direction of current induced in the loop ABC as shown. So first of all, we have a current carrying conductor. Okay, so current carrying conductor means current is passing in this direction, so point your thumb in this direction. So what is the magnetic field? Due to this wire, magnetic field will be into the page of the paper, because you have to curl your fingers. So curl your fingers and your fingers will point in the direction of magnetic field. So magnetic field through the loop will be into the page of the paper. Now if the current is constant, nothing is happening. Nothing is happening means flask is constant. Flask is there, but it is not 0, but flask change is 0. So if the current is constant, nothing is happening. So it will always, no current will be induced if the current is constant. Okay, so either current has to change, either decrease or increase. Based on that, we will say how the current is getting induced in the coil. So now we have to understand that if the current is increasing, then the magnetic field induced in this loop will oppose the change. Okay, if magnetic field is increasing, it will be in the opposite direction. If the magnetic field is current is decreasing, current decreasing means magnetic field is decreasing. So in that case, the induced current will try to increase the magnetic field. It will try to keep the magnetic field as it is. This loop will try to keep the magnetic field as it is, so that it does not have to do any work. Okay, so that is why when the magnetic field is increasing, it will try to reduce it. If the magnetic field is decreasing, then it will try to increase it. Okay, so in case of increasing current, the magnetic field will be out of the paper. Okay, the induced EMF, and if the current is decreasing, the induced EMF will be into the paper. The direction will be such that it will be into the paper. So let's see what are all the given options here. Along ABC, if I is increasing. So if I is increasing, what I said, it will be out of the paper. So current will be like this, so that your thumb points out of the paper. So it will be ACB. So if current is increasing, it will be ACB. Okay, so definitely ACB will be current is increasing. Along ACB, if I is decreasing, so they are pairs. Again, ACB is current is increasing. ACB is current is increasing. So definitely this is not also correct. Now along ABC, if I is decreasing. If I is decreasing, what will be the direction? It will be into the paper, right? As I said, if it is decreasing into the paper, that means ABC, it will be into the paper. So along ABC, if I is decreasing. Along ACB, if it is constant case, no current flows. So definitely that is out of the option. Next question. The dimensional formula for inductance is another interesting question. How to answer? This is a very tricky, difficult thing to remember. Sir, how many dimensions I have to remember? Yes, you have to remember few dimensions. Other one you can find. Now here try to find, if whenever you are trying to do any dimension related question, okay, if they are related to easier dimensions, for example force or energy, okay, or power, if they are related to these quantities or not. If you know some relationship which directly relates it to the mechanical dimensions, it is basically easier for you to find, because dimension of force is basically mlt to the power minus 2, right? So this is the dimension of force. This is a very first thing that you have to remember. Second, dimension of energy. Energy is what? Energy is you multiply one more dimension, one more length to it, right? Fx work done is equal to Fx cos theta. So from there basically you are adding one more length to it. So this is the dimension of force, okay, and dimension of energy or work done, whatever you call it, energy or work done, is basically m L square t to the power minus 2. These are the mechanical dimensions, easy to remember, okay. Now in case of inductance, the energy stored in an inductance, we know the formula, energy stored in an inductance is half L I square. Here L is inductance, don't confuse with this length, okay. So here L is inductance. So from here we can find the dimension of L, okay. Half is basically dimensionless, does not matter. So E, we said what is the dimension of E? M L square t to the power of minus 2. This is the dimension, this is the mechanical dimension. Now half is dimensionless, we ignore it, and we are trying to find the inductance L, not length L. Don't confuse, as I said. Let me write it in a bold letter so you don't get confused. This is the inductance L. And I, what is the dimension for I? I is ampere or A square. I square means A square, obviously. Now you have to find the dimension of this bold L. So bold L is basically dimension is ml square t to the power of minus 2 was already there, and this one comes here and joins them and says okay, I will become minus 2. So this is my home now. So this is the dimension of inductance, ml square t to the power of minus 2 a to the power of minus 2. If you remember, well and good. If you don't remember, like me, I used to do it like this way. So I taught you my secret, how I used to find the dimensions. This is a way you can find. So always try to remember corresponding mechanical dimensions if possible, easier dimensions. Inductance of a coil is independent of the geometry of the coil, the medium inside the coil, the current through the coil, the number of turns in the coil. So inductance basically does not depend on the current, okay. Inductance for a given coil is constant. So it depends on the geometry, it depends on the area, it depends on medium, it depends on mu, whatever is inside the coil. It is dependent on the number of turns per unit length. So definitely it is only independent of the current through the coil, okay. Even though the induced EMF can change, but current is basically, inductance is constant, okay. Based on the inductance it will give a response to the circuit. Now the phenomena of induction of an EMF in a coil due to change in the current through the same coil is called, so induction of an EMF by changing the current through the same coil, it is called self-induction. Self-induction, okay. Mutual induction is when one coil is linked with another. Which physical quantity plays the role of electrical inertia? So I already said in my live session, if you remember or if you have attempted, motional EMF, mutual inductance, induced current, self-inductance. So very close mutual and self-inductance fight between them, but motional inertia is basically self-inductance, because for mutual inductance to happen you need to have another coil, okay. But self-inductance you don't need anything. Even if there is one coil, it will still oppose the motion, okay. If the current flowing through a coil is doubled, the magnetic energy stored by it is also doubled, becomes half, becomes 4 times, becomes 1/4 of the initial value. So current flowing through the coil is doubled, the magnetic energy stored by it. So magnetic energy stored by it is basically half Li square. So if you double the current, then the energy stored will be 4 times of that of initial value. Okay, so it becomes 4 times. Okay, another matching cell, here we have 1 2 3 4 level of matching. Let's see. So self-induced EMF is called back EMF. Self-induced EMF is called back EMF. If you don't know, well and good, skip to the next, check the next one. EMF induced in a rod moving in a magnetic field. This is easy. This is called motional EMF. Okay, single rod motion. So this is motional EMF. Okay, AC generator. We do not know what is AC generator is about. Let's see. Transformer works under the principle of mutual inductance. So this is the option R. So definitely Q will be the last match. Okay, so for AC generator, electromagnetic induction by changing the orientation of the loop. So definitely this is correct. Now let's see. A is matching with S. A is matching with S in 2 cases. Obviously the next B is matching with P. So B is matching with P also in 2 cases. Next C is matching with Q. C is matching with Q in only 1 case. So definitely option A is the correct match in this case. Okay, so you have to check one by one level after another to find the correct answer. Next question. In an AC generator, when the plane of the armature is parallel to the magnetic field, both the magnetic flux and EMF are maximum. So what they have said, the plane of the armature are parallel to the magnetic field. So basically this is the plane and here we have a magnet. Okay, the magnetic flux and EMF are 0. The magnetic flux is 0 and EMF is maximum. The magnetic flux is maximum and EMF is 0. So when this happens, okay, the flask linked with, definitely you can see that flask, no field lines is passing directly through the wire. So flask is 0 but EMF is maximum. So the magnetic flask is 0 and EMF is maximum is the correct answer in this case. Next question. So here we have a wire like this. The figure shows a long straight current carrying wire placed along the axis of a circular conducting ring when viewed from above. So you have to check from above. The induced current in the ring is clockwise if the current through the wire is increasing. So similar question, we have seen one more induction question. So here the current is carrying current in the upward direction. Okay, so upward direction means what is the direction of a magnetic field through this? The magnetic field through this, definitely it will be magnetic field will be like this in a circular way. Now in this case, as you can see that the magnetic field is basically on the plane of the same plane of the coil, right? So basically in this case there will be no induced EMF. Okay, no induced EMF, there is no induced current in the ring even when the current through the wire is changing. Okay, there will be no induced EMF because it is in the same plane as the magnetic field. So flask through the coil will be 0. Flask will not change. Flask not change means there will be no induced EMF. Okay, so it will be out of the paper from this side and it will be into the paper from the other side, so that they try to reduce oppose the whatever field that is causing this current to flow. There is another way to do it. You can use the Fleming's right hand rule, but that is slightly complicated if you are not used to. But you can apply that same thing, whether whatever direction the rod is moving, it will be opposing the existing field. So it will be into the paper. It is out, cross means into the paper, so dot means out of the paper, so it will be out of the paper. So current should flow from the rod in the upward direction. Okay, that is sufficient. So as long as you can find one direction and then you use your thumb rule that okay, current should flow in the upward direction, that means what is the meaning of that? Upward direction means definitely this is the positive and this is the negative, right? Sorry, yes. So no, sorry, this will be positive, my mistake, and this will be the negative. So current will flow like this. Current will flow like this. Okay, so current will flow like this. Okay, similarly here it will flow like this. Okay, so in case of the left hand side it is anti-clockwise, on right hand side it is clockwise. Okay, so right hand side it is clockwise, flowing clockwise direction, it is left hand side it is anti-clockwise. So the direction of induced current in the left part is anti-clockwise, whereas in the right part it is clockwise. So option A is the correct answer. You can use right hand rule if you are comfortable using that, that is also fine. Otherwise this is the other way, that how can you find the direction. Okay, next question. The angular speed of the rotating armature of an AC generator is increased. The frequency of the AC increases while the peak EMF remains the same. Okay, the peak EMF increases while the frequency of the AC remains the same. Both frequency of the AC and the maximum EMF increases. Both frequency of the AC and the maximum EMF remains the same. So angular speed of the rotating armature of the AC generator is increased. So if you increase the angular speed, that is omega, okay, the EMF induced is directly proportional to the angular speed. So if you increase the armature speed, basically it will your peak EMF will increase while the frequency of the AC will remain the same. Okay, peak EMF increases, frequency remains the same. Statement 1. When two coils are wound on each other, the mutual induction between the coil is maximum. Mutual induction does not depend on orientation of the coils between the two statements. Statement 1 is true, false, etc., etc. Let's see. When two coils are wound on each other, the mutual induction between the coil is maximum. So when you wound one coil and another coil on top of that, obviously the mutual induction is maximum. Why? Mutual induction does not depend on the orientation of the coils between the two statements. Obviously it depends on the orientation of the coils. How it depends is not part of the syllabus, but it is given as a statement in your NCERT book, that it depends on the orientation. So statement 1 is true, statement 2 is false. So option C is correct. Next question. The use of laminated core in a transformer reduces the loss due to flux leakage. Eddy currents, my mistake. So laminated core means it basically reduces the eddy currents. If you study your NCERT book, you will know that this is one of the loss in the transformer, and it is reduced by laminated cores. The frequency of AC is increased. The impedance of a series LCR circuit continuously increases, continuously decreases, first increases and then decreases, first decreases, then increases. Okay, so if you increase the frequency, okay, in an LCR circuit, then what happens? The impedance, basically, what is the value of impedance? Impedance is square root of R square plus XL minus XC whole square, right? This is the formula for impedance. Now as you are increasing the frequency, what happens at resonance? When the resonance happens, this quantity becomes 0. This becomes 0. So impedance is minimum at this case. For all other cases the impedance is more. So basically what happens is the impedance first decreases, it becomes minimum, and then it increases. So this is the R value. Okay, for all other values it is more than that of the R. So it is first decreases and then increases for impedance. Okay, very careful. If they are talking about impedance, if they are talking about current generally increases first, then decreases. Okay, it reaches a maximum value. But in case of impedance, generally it attains the minimum value, that is equals to R, and then it increases again. Power factor for a purely resistive circuit. Power factor for a pure resistive circuit is unity, that is cos phi. Okay, phi is 0, so cos phi is 1 for purely resistive circuit. At resonance, a series LC or AC circuit behaves like a purely capacitive circuit, purely resistive circuit, purely inductive circuit, LC circuit. It behaves as a purely resistive circuit. Okay. At resonance, inductance and capacitance, they cancel each other. The power factor of a series LCR circuit is maximum when same thing. So power factor is maximum when XL equals to XC. So that is the maximum value. Cos phi equals to 1. So at resonance, the XL and XC, they cancel each other. So power factor becomes maximum. Which one of the following statements is wrong? AC can be easily and efficiently stepped up or stepped down. Yes, correct. It is economical to transmit DC over large distances. No, it is economical to transmit AC over a large distance. So we have found our false statement. This is the false statement. Let's see the other options. The average value of sinusoidal alternating current or voltage over a complete cycle is 0. Correct. The average power consumed by an AC circuit over a complete cycle may not be 0. Yes, that is also correct. In a purely capacitive circuit, the frequency of AC is doubled. The capacitive reactance will. So capacitive reactance XC is 1 by 2 pi FC. Okay, so if you increase the frequency, then XC will be halved. Okay, so they are inversely proportional. So if you increase the frequency, then it will be halved. It get halved. Okay. The phenomena of resonance exhibited by an AC circuit only if both L and C are present, only L and R are present, only if both R and C are present, only R is present in the circuit. So you get this resonance only when both L and C are present in the circuit. The dimensional formula of LC is L is self-inductance and C is capacitance. Okay, what is the dimensional formula for LC? Okay, very interesting. So we know that at resonance, the resonance frequency is given by 1 by 2 pi square root of LC. Okay, so this is our starting point in this case. Now what is the dimension for frequency? Frequency's unit is hertz. Unit is hertz. Hertz is nothing but per second. Okay, so its dimension is per second, that is t to the power of minus 1. Okay, this is the dimension of frequency. So what is the dimension of 1 by root LC? 1 by root LC is basically same dimension as frequency, that is t to the power of minus 1. Okay, sorry, just let me, my arrows are little, lines are little bigger. Okay, so this is the t to the power of minus 1. Now if you square both sides, you will get LC. LC is basically t to the power of minus 2. So LC, now you have to take the reciprocal. So LC will be t square. LC will be t square. So correct answer is option B, t square. Next question. At resonance, the voltage across the resistance is equal to voltage across L, voltage across C, the applied voltage, the sum of voltages across L and C. So this is also very careful. At resonance, L and C voltages, they cancel each other. So the voltage across resistance is basically same as the applied voltage. So because XL and XC, they can negate each other. They negate each other means definitely the applied voltage will be applied to the resistance only. Now column 1 is list of components through which alternating current is passed. The column 2 lists the quantities related to the column 1. Match the column 1 with column 2. Pure resistor, pure capacitor, pure inductor, a series LCR circuit. So these are the column 1. Column 2 is the current leads the voltage by pi by 2. So current leads the voltage in case of pure capacitor. Current lead the voltage by pi by 2 is pure capacitor. The current lags behind the voltage by pi by 2, that is pure inductor. So this is pure inductor. Okay. reactance of the circuit is independent of the frequency of the AC. Reactance means impedance or resistance, whatever you say. So reactance is independent of the frequency. That is only case of pure resistor. Okay, resistor is independent of AC. Average power dissipated over a complete cycle is non-zero. That is also possible for pure resistor. It is also possible for LCR circuit. Okay, so slightly ambiguity is there in this question. Okay, average power dissipated over a complete cycle is non-zero. That is true for pure resistor as well as LCR circuit as well. Okay. But from the given option, reactance of the circuit is independent on the frequency is not the case for LCR circuit. It depends on the frequency of the input frequency. So definitely D is not matching with R. So from this given option, this is the possible answer. A is matching with R, B is matching with A is matching with R, B is matching with P. Okay, B is matching with P, and C is with Q, and D with S. So option B is the correct answer in this given match. Next, a light bulb and an open inductor are given are connected as shown to an AC source through a key as shown in the figure. The switch is closed, and after some time an iron rod is inserted into the interior of the inductor. As the iron rod is inserted, the glow of the light bulb will decrease, increase, unchanged, increase or decrease. So as you are inserting the iron rod into this inductor coil, what happens is that the inductance increases. Inductance increases means basically it will have a higher XL. Okay, so XL is basically omega L. Now if L increases, the reactance will increase. Reactance increase means basically the impedance will increase. So impedance is like resistance. So if you increase the resistance, bulb glow of the bulb decreases. Similarly here reactance increases, so bulb of the glow will decrease. Next question. The following figure represents the variation of voltage and the current of an AC with the time. The solid line represents the instantaneous voltage, while the dashed line represents the instantaneous current. From the figure, we can infer that current is purely circuit is purely resistive, purely inductive. A series LCR circuit with XL greater than XC, series LCR circuit with XL equals to XC. So purely resistive is not possible. If purely resistive was there, then definitely the current and voltage phase should have matched, but as you can see, the phase is not matching. Okay, so this is the voltage, this is the current. So the peak of current is appearing before the peak of the voltage. So current is basically leading. Okay, current is leading because its peak is coming faster. Okay, so it is its peak is coming faster, so it is going to maximum value quicker than the voltage. So definitely current is leading. This is called current is leading. Okay, similarly you can see that the first zero of the current is coming before the zero of the voltage. That means current is leading the voltage. Okay, whoever is happening faster, he is leading, right? So this is why so this is called current is leading, whereas voltage is lagging. Now current is leading, voltage is lagging, and that angle is also not 90 degree. 90 degree means if they are happening exactly in opposite, so when it is going maximum, the other one is going to minimum. If that was happening, then you could have said angle was 90 degree. So if one is maximum, another one is zero, then you said okay, they are basically 90 degree phase difference. But that is also not happening. So 90 degree phase difference is also not the case. So definitely not purely inductive. In case of inductance anyway, current would have been lagging, but in this case current is leading. Current leads only when circuit is capacitive. Current leads only when the circuit is capacitive. To be a capacitive circuit, the XC has to be greater than that of XL. Okay, XC has to be greater than that of the XL. So basically it's a series circuit with XL is sorry, my mistake. XL should be less than that of the XC. Yes, sir. Yes. So XL must be less than that of XC because it's a capacitive circuit. So capacitive circuit means option D is the correct answer. Next question. The input voltage of a pure inductor is V is equal to Vm sin omega t. Then the current in the circuit is, so in case of pure inductor, current lags by angle pi by 2. So sin omega t and minus pi by 2. So option C is the correct answer. Next question. In a series LCR circuit, the L and C are interchanged. The resonance frequency of the circuit will increase, decrease, remain same. Okay, it does not depend on the relative position of L and C. As long as same value is there, the resonance frequency will remain unchanged. Displacement current is produced due to constant electric field. So we have already crossed 111 questions, right? 110 questions we have solved. One more, another 100 questions are yet to be solved. So displacement current is produced due to constant electric field, constant magnetic field, changing electric field, changing magnetic field. So displacement current is produced by changing electric field. So the expression for displacement current is ID equals to epsilon naught d phi E by dt. Remember that mu naught is not in the expression for ID. I multiple times said that, so don't get confused. Okay, so it is epsilon naught, it is due to change in electric field, and electric field is associated with epsilon naught only. Mu naught is from magnetic field, but here is no magnetic part. This mu naught is coming from the Ampere's circuital law. Okay. Choose the false statement. The electromagnetic waves are produced by accelerated charged particle. Yes, correct statement. The electromagnetic waves, for electromagnetic waves, E naught by B naught equals to C, where E naught and B naught are electric and magnetic field amplitude. Yes, correct statement. Electromagnetic waves are transverse in nature. Correct statement. Electromagnetic waves can be deflected by electric field and magnetic field. No, even though they are getting produced by electric and magnetic field, they cannot be deflected by them. So this is an incorrect statement. Next question. Out of the following options, which one can be used to produce a propagating electromagnetic wave? A chargeless particle, an accelerating charge, a charge moving at a constant velocity, a stationary charge. So basically an accelerating charge can produce a propagating electromagnetic wave. Which electromagnetic wave used in long range communication? Gamma rays, infrared rays, radio waves, microwaves. Okay, so long range communication is basically happened using radio waves. So answer is radio waves. The increasing order of wavelength of infrared, microwave, ultraviolet and gamma rays is, so increasing order, that means smaller to higher value of wavelength. Okay, gamma ray has the smallest wavelength. After gamma ray, so this is the highest wavelength, smallest wavelength. Ultraviolet is the next in the line, so it has the second lowest wavelength. Okay, then we have infrared rays, so they are third, and microwave is almost at the range of radio waves, so they are the fourth. Okay, so 1, 2, 3, 4. Gamma rays, ultraviolet and infrared, and then microwave. So option B is the correct answer. So if you see only one, if you figure it out that gamma ray is the smallest wavelength, you can answer it, right? The wavelength range for X-rays. So the wavelength range for X-rays is basically 0.1 10 nanometer to 10 to the power of minus 4 nanometer. Okay, this is the range for X-ray, and this is, I think, is for gamma ray. Millimeter is obviously not for X-ray. Nanometer is generally our visible light. This is for ultraviolet ray, by the way. The angle between the electric field and the magnetic field in an electromagnetic wave is always 90 degrees. Okay. The ultraviolet region of the electromagnetic wave spectrum lies between X-ray and visible region. Yes, ultraviolet is between X-ray and visible region. So correct answer is option A. You can check. Gamma is nothing near to the ultraviolet. Visible region and microwave, no. IR region and radio region, no. Okay, so obviously not. Statement 1. Displacement current goes through the gap between the plates of a capacitor when the charge on the plate of the capacitor does not change. So displacement current does not go through the capacitor when no charge is there, right? So only when the capacitor is charging, the displacement current goes through the plates of the capacitor. So this is a wrong statement. This is a wrong statement. Statement 2, the displacement current arises in the region in which the electric field is constant with time. So displacement current does not arise in the region which electric field is constant. It is basically changing electric field, right? So displacement current is basically related to changing electric field. So both statements are wrong. Option D is the correct answer. So first time I have seen both statements are wrong for a long time. Now, next, the electromagnetic wave suitable for radar system is basically radio waves or microwaves. Okay, if you see the microwave, that is also correct option. Okay, radar system mostly use either microwaves or radio waves. Statement 1, electromagnetic waves are transverse in nature. The electric and magnetic fields in the electromagnetic waves are perpendicular to each other and to the direction of propagation, and that is why it is called transverse. Transverse means whoever is producing it, they are in the perpendicular direction to the motion of the wave, right? That is a transverse wave. So in this case, electric field is vibrating in the perpendicular direction. Electric and magnetic both are perpendicular, and this is the direction of propagation of light. So definitely statement 1 and 2 are correct, and it is a correct explanation as well. So option A is correct. Next question. The velocity of electromagnetic waves depends on the electric and magnetic properties of the medium. Yes, electromagnetic waves, even though electromagnetic waves generally travels fast, but it depends on the properties of the medium. The velocity of the electromagnetic wave in free space is constant. It is also constant in free space. So both statements are correct, but did you find any relationship between them? There is no relationship between them. So electric field and magnetic field, it depends on the electric and magnetic properties, because based on that the speed can vary. Okay, so we know that as you change one medium to another, okay, the magnetic mu naught and epsilon naught changes. So if mu naught and epsilon naught are changing, that is it is becoming mu and epsilon. Based on that, we know that speed of a light in a medium is basically 1 by epsilon mu. In case of free space, it is basically 1 by mu naught epsilon naught. Now mu naught and epsilon naught are constant, that is why C is constant, but it definitely depends on the magnetic and electric property. This is electric property, this is magnetic property, so it depends on them. So both statements are correct, but there is no the correlation, there is no correct explanation. So option B is correct in this case. Okay. Speed of light according to Maxwell's equation, I just told you in the previous case, C is basically 1 by mu naught epsilon naught. Infrared radiation plays an important role in the maintaining the average temperature of Earth. Okay, infrared radiations are sometimes referred to as heat waves. So yes, during the night, the radiation that Earth emits, which is called the heat waves, that is basically maintaining the temperature of Earth. Okay, so basically both statements are true, and 2 is the correct explanation. Okay, basically the heat that is getting emitted by Earth is in the form of infrared ray. That is why it is called heat waves, and that is why it is helping us to maintain the atmospheric temperature. Next question. In refraction of light, sin I by sin r equals to 1, I by r equals to constant, sin I into sin r equals to constant, sin I by sin r equals to constant. This is Snell's law. This is the correct statement. Okay, the first one is true for reflection. Okay, second one is also true for second one is not exactly true for reflection. The sin I by r equals to 1 definitely, and third one is not constant anyway. Next question. For total internal reflection of light, light should travel from rarer to denser medium. Light should travel from denser medium to rarer medium. Yes, for total internal reflection, light should travel from denser to rarer medium. So option B is correct. Okay. let's check other options as well. Sometimes they mention both A and B, so just so for that cases you have to check other options as well. Light should be incident along the normal, no. Angle of incidence should be equals to 90 degree, no. So other options are incorrect. An object of finite height is placed in front of a concave mirror within its focus. It forms a real enlarged image, real diminished image, a virtual enlarged image, virtual diminished image. So what is the mirror? It is a concave mirror. A concave mirror can form real as well as virtual images both. Okay, and where it is placed? It is placed in front of a concave mirror within its focus. Within its focus means the distance is less than the focal length. So if this is the focus, the object is placed within its focus. Okay, so within its focus means obviously the image formed will be virtual and erect and enlarged. So it will be a virtual and enlarged image. The speed of light in a medium depends on angle of incidence, angle of refraction, refractive index, its mass density. So speed of light in a medium depends on not angle of incidence, not angle of refraction. It depends on the refractive index only. Okay. Refractive index of the medium depends on thickness of the medium, angle of incidence, mass density of the medium, optical density of the medium. Okay, refractive index is basically a reflection of optical density, how much optically denser a medium is. So this is the answer. Next, when light ray travels from rarer medium to denser medium, its velocity increases, its velocity decreases, wavelength increases, frequency decreases. Frequency does not change. Okay, frequency does not change no matter what medium you are going. Wavelength and speed can change. So when the light travels from rarer, in case of rarer medium, speed of light is more. Okay, in denser medium, speed of light is less. So speed of light decreases or velocity decreases. Wavelength also changes. You can find out there is a relationship, V is equal to nu lambda. Nu is frequency, so if velocity decreases, wavelength will also decrease. Okay, nu remains constant. Nu is the frequency which always remains constant for a given light. Snell's law fails in the case of, Snell's law fails, wow. When light travels from denser to rarer medium, oblique incidence. When light travels from rarer to denser medium, normal incidence. So Snell's law fails in case of normal incidence. Normal incidence means, what is the meaning of normal and oblique incidence? So this is called a normal incidence. When the light is falling along the normal, this is called normal incidence, and if the angle is other than this normal, that is called oblique incidence. This is called oblique. Okay, so during my live session some student asked me what is the meaning of oblique. So if you don't know, this is called oblique, this is called normal. The principle of optical fibers is reflection of light, diffraction of light, dispersion of light, total internal reflection. Easy question. Let's move on to the next question. The focal length of a lens depends on the refractive index of the material, radii of curvature of the two surfaces, diameter of the aperture. Okay, so what is the focal length formula? Focal length formula is n minus 1 by r1 minus 1 by r2, right? So focal length depends on the refractive index and radii of curvature. Radii of curvature is a plural of radius, right? Radius is a singular word, radii is a plural word. So both option 1 and 2 are correct, 3 is not correct. So both only option 1 and 2 are correct. Two thin lenses of focal length f1 and f2 are in contact. The power of the combination. So power of the first lens 1 by f1, power of the second lens 1 by f2. So this is the combined power, right? This is the combined power. Power simply gets added like scalars. So what is this will be? It will be f1 f2 by f1 plus f2. This is the power. Okay, f1 plus f2 divided by f1 f2. The angle of minimum deviation of a prism is depends on only angle of the prism, only refractive index of the prism, angle of incidence, both angle of the prism and refractive index. So angle of minimum deviation is dependent on both angle of prism and refractive index. It does not depend on angle of incidence. Obviously there is some angle at some certain angle of incidence, it will be minimum, but that angle basically depends on the refractive index and angle of the prism. A ray of light is incident on a glass air interface at an angle greater than the critical angle of the pair of the media. Then the ray undergoes total internal reflection. Okay, light ray incident on the glass air interface at an angle greater than the critical angle. So total internal reflection, it will be equal to critical angle, then grazes through the surface. So be careful if the same question was asked in a different language. The magnification of the refracting telescope is FO by FE. Statement 1, a convex mirror is preferred over a plane mirror in a vehicles to observe traffic coming from behind. Convex mirrors have a large field of view and images of real objects formed by convex mirror are erect. So, convex mirror generally have a large field of view, so light from all different angles can gather and they can reach your eye. So from here you are observing, that is why convex mirror are used as rear view mirrors. Okay, that is preferred to observe whatever is coming from behind, that is also called rear view mirrors. So definitely both statements are correct. And as I said, there are few questions where option A they have given not correct explanation, so you have to be careful. The correct explanation, this is the correct explanation, both are correct, and statement 2 is the correct explanation. Okay, so option B will be correct in this case. I think this is an anomaly, but you do not know, you have to read the question paper. The image forms formed by total internal reflection are much brighter than so I think this is a redundant, you can delete it. Image formed by total internal reflection are much brighter than those formed by mirrors or lenses. In total internal reflection, the light is completely reflected and there is no loss of intensity of light. So we know that in total internal reflection it is a totally reflected light, so no loss of energy here, so that is why the image formed is very bright. So both statements are correct, and statement 2 is the correct explanation, so option B is correct in this case as well. Two light sources are said to be coherent when both sources of light emit light of same amplitude and phase, same intensity and wavelength, same speed, same wavelength and constant phase difference. So phase difference has to be constant. Okay, that is the case for coherent sources. Okay. In Young's double slit experiment with monochromatic light, how is fringe width affected if the screen is moved closer to the slits? It is independent, it is remains the same, increases, decreases. So what you are doing, we are doing Young's double slit experiment using monochromatic light. How the fringe width affects? So what is the formula for fringe width? Fringe width is lambda d by d. Okay, if the screen is moved closer to the slits, that means what is happening, you are decreasing the d. So if the entire system is now moved closer to the distance, then definitely distance d is decreasing. Distance d decreasing means fringe width will decrease. Okay, fringe width decreases. What would be the resultant intensity at a point of destructive interference if there are two identical coherent waves of intensity I naught producing an interference pattern? So definitely two equal waves of I naught, they are interfering. So I naught interfering means definitely the intensity will be 0. Okay, to equal and opposite definitely means they will cancel each other. Cancel each other means the resultant intensity will be 0. So correct answer is option C in this case, right? Let's move on to the next question. A beam of unpolarized light of intensity I naught is passed through a pair of Polaroids with their pass axis inclined at an angle of theta. the intensity of the emergent light is equals to, okay, so first Polaroid, there are two Polaroids, one Polaroid, second Polaroid, unpolarized light coming here. So unpolarized light coming here means as soon as it passes through the first Polaroid, say P1, okay, the intensity of the light, suppose the intensity was I naught as given, once it passes through the first Polaroid, the intensity becomes half. This is the first time polarization. So whenever an unpolarized light passes through a Polaroid for the first time, its intensity basically becomes half, okay. Now when it is passing through the second Polaroid, so of angle say theta, it will be I naught by 2 into cos square theta. So whatever light intensity is entering this, same intensity times cos square theta, that is Malus law. So it will be I naught by 2 whole square into cos square theta. So correct answer is option D, okay. To observe sustained interference pattern on a screen placed at a suitable distance in Young's double slit experiment, which of the following conditions are necessary? Sources of light should be coherent, yes. Sources of light should be narrow, yes. Sources of light should be very close. Now sources of light should be very close is not a necessary condition, okay. Sources of light should be narrow, yes, correct, because it should be of the order of the wavelength lambda, okay, and sources should be coherent. Now sources of light should be very close is not a necessary condition, they should be close so that you can observe the interference, okay. They should illuminate the same place so that you can observe the interference. The closeness is not super necessary, yes, if they are close you will get a good pattern, but that is a good to have a condition, not a necessary condition. So necessary condition means exactly necessary, so that is option A and B, okay. Both option A and B are necessary condition, okay. Next, according to Huygens principle, the speed of the secondary wavelet is twice that of the wave, 0 same as the wave, okay. Next, when a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wavefront is spherical, convergent wavefront, spherical divergent wavefront, plane wavefront, cylindrical wavefront. So what is the case? They have given you a convex lens, right, and light is placed on the principal focus. So light is traveling like this. So this is a focal length. So focal length means after passing through this will become parallel. So parallel means the wavefront will be plane parallel, okay, plane wavefront, okay. Option C is the correct answer. 148, shape of the wave in front of light coming from a distant star, okay. Shape of the light again coming from a distant star, the star is very far, so by the time it reaches to our eyes they become almost parallel to each other, so again it's a plane wavefront. Parallel light means plane wavefront, okay. If they are emerging from like this, then it is called spherical wavefront. If you can match them using a sphere, it is called a spherical wavefront. Point source is spherical wavefront, okay. Very distant source is a plane wavefront. Lens, when the object is placed at focus, is plane wavefront. And in case of say a line source, a tube light, okay, the wavefront is basically cylindrical wavefront. So these are the different shapes of the wavefront that you have to remember, okay. Now next question, 149, the principle of superposition of wave applies whenever one source of light falls on a screen, okay. One source of light moves across a screen, two or more sources of light illuminate the same point, okay. So two or more sources of light illuminate the same point, that is the principle of superposition. Obviously if they are illuminating separately, there is no superposition. Superposition means one has to superimpose over another, right? So that is the correct answer. We have a constructive interference if the path difference is integral multiple of lambda, that is delta x equals to n lambda, that is the condition for constructive path difference. Okay. Now if you are preparing for your KCET exam and you want to solve more questions with us like that we are doing today, because KCET exam is basically based on MCQs, as you know that, then we have launched a paid test series called Abhyas KCET test series, where you can practice total 35 tests will be given exactly at the KCET standard. Okay, after a lot of research and preparation, these question papers are prepared, and if you register right now from the given link in the description, then definitely you can have first four test paper for absolutely free, and those test papers will be given to you in a form of executable format. That is, you can click on this and then you will get a question paper. You can answer it option A, B, C, whatever is correct option, and there will be a timed monitoring of this. Once you submit the question paper, you will get a response which of the questions are incorrect, which of them you have corrected it. So everything will be in place once you purchase this test paper, but you can get the first four papers for absolutely free. Once your PU board exam is over from 17th of March onwards, we have extensive plan till your KCET final exam, 2025 KCET exam. You will get total another 31 test papers. Okay, that is completely paid, but for free you will get right now. Also during this series you will get detailed video solutions for all the question papers. You will get chapter wise one shot revision videos, you will get chapter wise insight for last 5 years KCET papers, and if you purchase now with the 1499, which is almost half of the actual price, you will get limited time PU2 test paper test series absolutely for 1 rupee. That is 1498 is the price. If you paid 1 rupee extra, 1499, you will get PU2 test series absolutely almost free, right? So what is that PU2 test series? PU2 test series is basically preparation for your PU board, physics, chemistry, maths, biology, CS and Kannada. You will get that test series absolutely for 1 rupee only. Okay, excited? And if you want, you can go to the link below in the given description and register yourself today. Don't wait, maybe you will not get the chance to get this offer right now. Right now, let's move on to question 151. So we have almost at the end page, we have run this marathon for almost 3 hours. Now we have 1 more hour and we will complete this marathon. To observe diffraction, the size of the obstacle should be lambda by 2, where lambda is wavelength. So the size of the obstacle should be of the level of the order of the wavelength. It should not be lambda by 2 or lambda or 5 lambda, 10 lambda. It should be of the order of the wavelength. Okay, slightly difference from the lambda is okay, but it should be order of the wavelength. That means if the wavelength is 600 nanometer, then the size of the obstacle will be 610 nanometer or 700 nanometers, like, but it should not be less than that anyway. It should be of the order of the wavelength. Okay. Next, two lights of each intensity I0 are used in Young's double slit experiment. The intensity of the interference maxima will be 4I0. For minima it will be 0, for maxima it will be 4I0. When the compact disc CD is illuminated by a small source of white light, colored bands are observed. This is due to the interference scattering deflection. This is basically due to diffraction. While both light and sound show wave character, diffraction is much harder to observe in light. This is because, so if you think that what is diffraction, diffraction is basically bending of light around a sharp edge. Similarly, sound can bend from sharp edge. That is why, suppose you are talking to your friend who is residing on the other side of the boundary wall, you can still talk to them, because sound wave can easily cross through the boundary. Even if you are not seeing some person, he can able to hear you, because sound wave can diffract through the large boundaries as well. Okay, this is called diffraction. Otherwise, if it was traveling in a straight line, it should have been getting blocked, right? But sound wave has a very long wavelength, so it can easily cross and it can still reach to the person in the other side. So it is basically related to wavelength. Higher the wavelength, easier to observe diffraction. Smaller the wavelength, difficult to observe the diffraction, okay, because wavelength of light is smaller than that of the sound. Next question, which of the statements are correct with the reference to single slit diffraction pattern? Fringes are of unequal width, fringes are of equal width, light energy is not conserved, intensities of all bright fringes are equal. So in case of single slit diffraction pattern, the intensities are not same, so there is a central maxima, and its width is also the maximum. Not only its brightness, its width is also maximum, and slowly the intensity falls, drops quickly, okay. So fringes are of unequal width. So unlike in Young's double slit where you observe all the fringe widths are equal, in case of the single slit diffraction, fringes are not of equal width. Next, light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. Now we have moved to photoelectric effect. The incident radiation is made exceedingly dim. The photoemission will cease to exist. The photoemission will continue, but the saturation current will decrease. So as we know that the saturation current or the current that is flowing in the tube depends on the intensity, whereas the electrons coming out of the material depends on the light frequency of the light. It is independent of the intensity. So even if you have made the intensity less, exceedingly dim means you have decreased the intensity, but it is still glowing. So as long as it is glowing, you will get photoelectric effect, okay, but the saturation current will decrease. So correct answer is option B. In photoelectric effect, the time lag by electron emission is of the order of 10 to the power of 8 seconds. Okay. The de Broglie wavelength of moving particle is independent of dash of the particle, charge, mass, speed, momentum. So de Broglie wavelength is basically h by p, that is h by mv. So it depends on mass, it depends on velocity, it depends on momentum. Definitely it does not depend on charge. Emission of electrons from a metal surface by heating is called photoelectric emission, thermoionic emission, field emission, secondary emission. So you are heating, so this is definitely thermoionic emission. The photoelectric effect experiment, if only the frequency of incident radiation is increased, then the maximum kinetic energy of the photoelectron decreases, the stopping potential increases, the photoelectric current increases, photoelectric current decreases. So as I said, photoelectric current is independent of the frequency, it only depends on the intensity of the light. Intensity is constant, frequency you are changing. So frequency changing means maximum kinetic energy will increase. So maximum kinetic energy K max will increase, and not only that, that is basically equals to the stopping potential EV naught, that is equals to h nu minus nu naught. Nu naught is the threshold frequency, okay, and the work function is given by h nu naught, right, if you remember that. So what will happen? Kinetic energy increases, stopping potential increases if you increase nu, right? So but here the kinetic energy they are talking about decrease, so definitely not correct. So stopping potential increases is the correct option. The sufficient energy by the electron to overcome the attractive pull of metal surface is called work function, photoelectric effect, stopping potential, field emission. Okay, so you are allowing electrons to overcome the attractive pull by providing sufficient energy. So if you give sufficient energy to make the electron free, it is not a process, it's basically the work function of the material. It is not photoelectric effect, not stopping potential, not field emission, it is the work function. That this much work you have to do to free the electron. Now next 162, particle behavior of light was confirmed by following experiments: A.H. Compton on scattering of X-rays from electrons, Albert Einstein for photoelectric effect, Millikan of charged electrons, J.J. Thomson on discovering the experiment. Choose to correct option. Okay, The particle behavior of light was confirmed by following experiments. Now Albert Einstein did not do any experiment. He observed, he gave the theory for that. Okay, Compton did X-ray scattering, which is very, very important, which is the particle nature of light, and Millikan also did the experiment which actually proved the theory of Einstein. Okay, Millikan's experiment is linked with Einstein's theory, but this is an experiment, this is an experiment. So Einstein, if they have said that Lennard and Hallward and Lennard or Heinrich Hertz may be possible, but 1 and 2 are correct option, 1 and 3 are correct option, but here they have included option 2 as well, so 1, 2 and 3, but in reality Albert Einstein theory was important, but in the option they have mentioned experiments, which is my point of concern. Okay, I have taken this question from your question bank, and in this case this the statement of the question is not correct. This should be the theory or the experiment and research. Experiments and research, if they said, it would be correct, because Einstein did the research but he did not do the experiment himself. He only based on the Hallward and Lennard's observation, he did the theory part only, and he got Nobel Prize for that. Photon energy is independent of intensity of radiation, frequency of radiation, wavelength of radiation, none of these. So photon energy is independent of, photon energy is basically given by E equals to h nu. Okay, and it is basically given by c by lambda. Nu is c by lambda. So definitely it depends on wavelength, depends on frequency, but there is no intensity involved here, so definitely it is independent of, photons energy is independent of the intensity. In photon particle collision, which of the following is conserved? Only total energy is conserved, only total momentum is conserved, both total momentum and total energy are conserved, neither total momentum nor total energy is conserved. So in photon particle collision, X-ray scattering experiment, okay, remember that momentum and total energy has to be conserved. In any kind of collision, total energy, kinetic energy may not be conserved, but total energy and momentum has to be conserved. So both total momentum and total energy are conserved. The gathering and focusing mechanism of light by the eye lens is described by, so gathering and focusing of the eye lens is described by wave nature of light. Okay, there is but when the cone cells and rod cells that is present in our eye, they have some quantum mechanical property, but the gathering and focusing part can be explained by wave nature of light. You do not need particle nature of light. Macroscopic particles in our daily life do not show wave-like properties because they are associated with waves. They are not associated with waves. Their wavelengths are extremely high, their wavelengths are zero, their wavelength is negligibly small. Okay. So basically, and now if you tell me what is the difference between 0 and small, obviously small does not mean 0. So even if you run in a track, you have some wavelength associated with it, but that wavelength is very, 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 very small, and you cannot even detect that wavelength. Okay, no way you can detect that. Right, now next. The following statements relating wave theory to explain photoelectric emissions are: statement 1, the maximum kinetic energy of photoelectron is directly proportional to the frequency of light. Yes, maximum kinetic energy is proportional to frequency of light. The frequency of radiation can change the saturation current in photoelectric emission. The frequency of radiation cannot change the saturation current, only the intensity of light can change the saturation current. Okay, so photoelectron directly proportional to frequency, it is independent of the saturation current, is independent of the frequency. So both statement 1 is true but 2 is false, so correct answer is option C. The slope of stopping potential V naught versus frequency nu in Einstein's photoelectric equation. So very, very interesting. So if you plot the graph of frequency versus stopping potential, okay, you will get a graph like this. You have to find this slope. What is this slope? How to find that? So to find that, we have to remember that the normal equation y is equal to mx plus c. Okay, so if this is along y axis, this is along x axis, okay, so based, if you can write this equation, this graph, equation of this graph like this form, then you can say this is basically the slope, right? We know that this is the slope form of a straight line, so this is a straight line. So if you can write it in this form, definitely you can find the slope. Now what is the formula? We know for photoelectric emission, EV naught equals to h nu minus phi, which is work function, right? So what is y here? Y is V naught. So V naught is equals to h by e into nu minus phi by e. So this is the intercept and this is the slope. So h by e is the slope. So h by e is the slope for the photoelectric equation. Now photoelectric experiment, the wavelength of the incident radiation is reduced from 6000 angstrom to 5000 angstrom. Then frequency will decrease, stopping potential will increase, kinetic energy emitted electrons will decrease, the value of work function will increase. Now value of work function is independent, it only depends on the material, right? Now what is happening? If you remember, the relationship between frequency and wavelength is basically c by lambda. Okay, so if you decrease the wavelength, that means frequency is getting increased. So what is happening here? You are decreasing the wavelength, so frequency should increase. So frequency increasing means what? The energy of the photon is increasing. Energy of the photon means maximum kinetic energy is increasing. Okay, so and maximum kinetic energy increasing means stopping potential is also increasing. So kinetic energy not decrease, it is increasing, so stopping potential will increase is the answer. Okay, frequency is increasing, so frequency decrease is also incorrect. Photoelectric emission is emitting electrons on applying electric field, magnetic field, light. Be careful, photoelectric emission is when you are applying light to get electrons. The condensed matter and dense gases at all temperature emit electromagnetic radiation due to high temperature, oscillations of the atoms and molecules, head-on collisions between atoms and molecules, none of these. So condensed matter and dense gases all temperature emit electromagnetic radiation because oscillations of the atoms and molecules. Okay, this is also there in your NCERT textbook if you have missed it. The source of alpha particle in Geiger-Marsden experiment is radium, bismuth, radon, cobalt. It is basically bismuth 214, okay, a radioactive sample which emits alpha particle. Most of the questions from this chapter is memory based. The electron will fall into the nucleus. According to classical theory, electron will fall into the nucleus and accelerated electron emits radiation in the circular path. So basically what is the meaning of that? An electron, when it is orbiting in a circular path, it is basically in the acceleration mode. We know that centripetal acceleration, right? So an accelerated electron, what will happen? It will radiate the energy and slowly it will fall into the center, that is in the nucleus. So electrons will not stable, but that is classical theory, which is basically both statements are correct, and then statement 2 is the correct explanation. That is the answer, option A is the correct answer, because as the electron is spiraling in, okay, it will lose energy, right? Next, the detector in alpha particle scattering experiment is coated with silver nitrate screen, phosphorescent, barium sulfide, zinc sulfide. It is generally coated with zinc sulfide. The light emitted by mercury vapor lamp is due to statement 1, interaction between individual atoms. The average spacing between the atoms is large. Both statements 1 and 2 are correct. Both statement 1 and 2 are false, not correct. 1 is true, 2 is false. So the option 1 is given, interaction between, not option 1, statement 1, interaction between individual atoms. Yes, interaction between individual atom is obviously correct. So individual atom, when the electron going to the higher energy states and then it is coming back to the ground state, it is emitting the radiation. That radiation is basically we are receiving as light. So mercury vapor lamp or sodium vapor lamp, whatever lamp it is always the interaction between the individual atom. The average spacing between the atoms is large. Now average spacing is not important in this case. In case of mercury vapor lamp, the pressure is very high, so you cannot even comprehend what is the average spacing. So basically statement 1 is true but statement 2 is false. So size of the atom is basically 10 to the power of minus 10 meter, but size of the nucleus is 10 to the power of minus 14 to minus 15 meters. So atom is 10 to the power of minus 10 meters. So nucleus is basically 10 to the power 4 to 10 to the power of 5 times larger than that of the size of the atom. Okay. Next, the alpha particles are nuclei of helium plus 2 atom. Okay. But I don't think there is any difference between helium atom and helium plus 2 atom, because they are talking about nuclei. So helium plus 2 itself is the alpha particle. Helium plus 2 itself is the nuclei of helium, right? Rutherford alpha particle scattering experiment determines the size of the nucleus, electron, proton, neutron. Okay, Rutherford alpha particle scattering experiment determines the size of the nucleus. Okay, it determines the size of the nucleus. Next question, the negative sign in electrostatic potential energy of an electron signifies that the potential energy of the electron is unstable. The electrostatic force is in the negative r direction. The kinetic energy of all electron is constant. None of this. So negative sign in the electrostatic potential basically represents the force is opposite direction, that is negative direction. So this is the correct answer in this case, and also it explains that the electron is basically bound to the nucleus. It cannot move freely. Okay. The emission line spectrum is a characteristic of a molecule, a solid, an atom, a liquid. It's a property of characteristics of a atom. The emission line spectrum serves as paper print of gases, photo print of gases, color print of gases, fingerprint of gases. So basically emission spectrum is called fingerprint of gases. Interesting question. So basically you can identify a gas from its spectrum. Similarly to that, if you do a crime and if you leave a fingerprint in the crime scene, from your crime fingerprint they can determine, okay, it is you are the killer. Similarly fingerprint of the gases, if the gas is coming out from a very distant star, if you get the spectrum line matching with the some gas, then definitely there is a hydrogen gas present in that very distant star. So that is why you do the astronomy. It's very helpful in the astronomy to determine what is the material made up of in a distant galaxy. Bohr's atomic model imitates Sun-Earth system, Earth-Moon system, Sun-Planet system, Sun-Comet system. Obviously it imitates Sun-Planet system, not exactly Bohr's atomic model. It is actually Rutherford model. Bohr was very specific about the orbits. So in case of Rutherford's model, it was not specific, so you could have said Sun-Planet system was applicable to Rutherford system rather than Bohr system. The principal quantum number for Bohr radius is n equals to 1, so n square equals to 1, right? Bohr radius is the first radius. The minimum energy required to free the electron from the ground state of hydrogen atom is called first excitation energy, zero potential energy, excitation energy, ionization energy. So from the ground state it is called excitation energy. So it is actually free, or you can say zero potential energy, I think. Oh, sorry. It is called ionization energy. You take out the electron out of the hydrogen atom, right? So it is called ionization energy. Excitation energy is when you are exciting the electron from one state to another. If it is going from 0 state to the ground state to state 1, that is first excitation energy, right? But when you take out the electron completely, that is the ionization energy, that is 13.6 electron volt. Nucleus of an atom whose atomic mass is 24 consists of, so now we are talking about nucleus, 11 electrons, 11 protons, 13 neutrons. 11 electrons, 13 protons, 11 neutrons. So mass, atomic mass is 24. So basically what is the condition? You have to be sure that our nucleus cannot have electrons inside it. Okay, it cannot have electrons inside the nucleus, so option A and option B are incorrect. Okay, so 11 protons, so they have asked about nucleus only. Okay, so be careful. Okay, 11 protons and 13 neutrons. Okay, or 11 protons and 13 electrons. So obviously this is also not possible. But if they ask you about atom, okay, sorry, it can be possible. They have asked about they have said that nucleus of an atom whose atomic mass is 24 consists of, so only about, we are talking about nucleus, we are not talking about atom. Okay, so these two are not possible, as usual I said. And protons and electrons cannot be staying inside the nucleus. Only 11 protons and 13 neutrons is a possible combination. So we understand that the nucleus cannot have electrons inside it. Okay, only protons and neutrons combination are allowed, and in general the number of protons should always be less or equals to number of neutrons. In case in future if you see a question where number of protons are much more than that of number of neutrons, that is very unstable nucleus. It will decay in less than milli-microseconds. Okay, so that is not possible. In general, proton number will be less than that of neutrons. Up to some level they are equal, and after some level neutron number is generally higher. Isotopes are atoms having, so isotopes are basically same element but different mass number. Okay, same number of protons but different number of neutrons. Yes, number of protons determines the element, so same number of protons but different number of neutrons. Okay, radius of nucleus of a mass number A is proportional to A to the power 1/3. Okay, so radius of nucleus is, if you remember, r equals to r naught A to the power 1/3. So that is why the volume is you can calculate the volume, and density will be coming out to be a constant. Which of the following is correct for nuclear forces? Short ranged, attractive and charge independent, short range, attractive and charge dependent. Obviously it is charge independent, so option A and C we have to see. And nuclear forces are short range, so option A is the correct answer. Okay, first we checked whether they are charge independent. Charge independent nuclear force is independent of the charge. Same force acts between proton and neutron, and neutron and neutron. Neutron are basically independent of charge, right? They do not have any charge, neutral objects. So force between two protons, force between two neutrons, force between proton and neutron, everything is same. So they do not differentiate. Like in case of Coulomb force, it was dependent on charge. If you are charged or not. If you have charge, then definitely there will be some force between us. If you don't have charge, I will not attract or not repel you, right? Easy. Question number 190. Density of nucleus is 2.29 into 10 to the power of 17 kilogram per meter cube. So option B is the correct answer. Binding energy of a nucleus is, but that was a bad question, that should not come in your board exam. Energy given to its nucleus during its formation, total mass of the nucleus converted into energy units, energy required to break a nucleus into constituent nucleus. That is the definition of binding energy. The binding energy per nucleon is maximum in the case of So binding energy, if you see that it is a very high energy, so it is not uranium. Uranium's binding energy per nucleon is not very high. I think it will be helium. Okay, lesser is the energy. If you can check this out, I am not sure about this question answer. It is related to the this graph. Okay, you can check the graph. I think not even helium. The correct answer should be, I am not sure about this. It will be I think beryllium. Okay, this should be the material up to which the binding energy per nucleon increases. Okay, you can check that out and mention in the comment below. So consider this to be a homework for you. Okay, for effective nuclear forces, the distance should be 10 to the power of minus 10 meter, 10 to the power of minus 13 meter, 10 to the power of minus 15 meter, 10 to the power of minus 10 meters. It should be order of few fermions. So obviously 10 to the power of minus 15 meter is the correct answer. Okay, the alpha particle is the nucleus of an atom of helium. Radioactivity is reversible process, self disintegration process, spontaneous process, both B and C. It's a self disintegration process where an atom itself divided into two different, sorry, not an atom, a nucleus divides into two separate nucleuses, and it is a spontaneous process. So both B and C are correct. Radioactive substances emit alpha rays, beta rays, gamma rays, all of the above. Radioactive substances emit all types of rays. Fusion reaction takes place at a high temperature because atoms are ionized at very high temperature, molecules break up at high temperature, nuclei break up at high temperature, kinetic energy is very high, enough to overcome the repulsion between the nuclei. Okay, so what is the thing that at very high temperature you are fusing the nucleuses. Okay, so the nucleuses basically both are positive, so they are basically repelling each other. Very high temperature, kinetic energy sufficient to overcome that nuclear repulsion. So definitely option D is the correct answer. Nucleus cannot be broken apart in high temperature. That will be difficult. Okay. The explosion of the atomic bomb takes place due to nuclear fission, nuclear fusion, scattering, thermionic emission. This is called nuclear fission, where you are breaking. Okay. Fusion means you are joining. Energy generation in stars mainly due to fission of heavy nuclei, fusion of light nuclei, fusion of heavy nuclei. It is fusion of light nuclei. Fusion of heavy nuclei also occurs, but that is at the end stages of the star. Fusion reaction is initiated with the help of low temperature, high temperature. Okay, so at high temperature, for example, in sun, hydrogen, they are already at very 4,000, 6,000 degrees Celsius, and at that temperature, they fuse together and producing helium. That is happening rapidly in the sun, and that heat energy is getting transferred to our home, and our entire earth is basically receiving the sun's light. It is all our solar system is basically receiving the sun's light. Now valency of an impurity. Now we are last chapter, that is the semiconductor chapter. 15 more questions are there, and hopefully we will complete it very quickly. The valency of impurity added to a germanium crystal in order to convert it into a p-type semiconductor. So germanium crystal, tetravalent, okay, and you are making it a p-type. P-type means positive type. That means you need some donor elements. So donor impurity means 3. Okay, if it was n-type, then it would have been 5. Okay. The majority charge carriers in p-type semiconductors are holes. Semiconductor doped with the donor impurity is so donor impurity is n-type. Sorry, my mistake. Donor means who is giving the electron. If it is an acceptor, then it is a p-type. Okay, p-type is basically acceptor impurity, which is accepting the electron. That is why it is trivalent, and donor means whoever is giving away the electron. Okay, so my mistake, I corrected it. P-type semiconductors can be obtained by adding arsenic to pure silicon, gallium to pure silicon, antimony to pure germanium, phosphorus to pure germanium. Phosphorus, antimony, and arsenic, they are all pentavalent, so they are all will give you n-type. Only gallium, which is a trivalent, will give you pure. If you add it to any of the semi, does not matter if you are adding it to germanium or silicon, you will get a p-type semiconductor. The thickness of depletion region is of the order of micrometers, so option 1 is correct. The diffusion current in a PN junction is greater than that of the drift current in magnitude if the junction is forward biased, if the junction is reverse biased, the junction is unbiased, both A and B. So diffusion current in a PN junction is greater than that of the drift current. So drift current is basically what is happening when you are having a diffusion current. Diffusion current is basically when suppose this is P type, this is N type. So from electrons came here and some holes came here, so they are now blocking the path. Initially what happened, the electrons were traveling in this side, so this is basically the diffusion current. Okay, this is the diffusion current, and the drift current is when normally electrons are drifting under the applied electric field, right? So diffusion current generally is more in case of reverse bias case. Okay, when the reverse junction is reverse bias, diffusion current is more and the drift velocity is less. When a PN junction is reverse bias, electrons and holes are attracted towards each other and move towards the depletion region. The electrons and holes move away from the junction of depletion region. Height of the potential barrier decreases. No change in the current take place. Now the options are a little complicated, but when you are considering an ideal PN junction diode and they are it is reversed bias, there is no current flowing in the circuit, so no change in the current is observed. That is, the current change is very, very small. The cut-in voltage for silicon diode is, so the cut-in voltage for silicon is 0.7 volts. The PN junction diode is used for an amplifier, a rectifier, an oscillator, a modulator, a rectifier. Now output of a full wave rectifier is pure AC, pure DC, pulsating DC, pulsating AC. So what is the meaning of pure DC? Pure DC, as I mentioned, if you have followed me previously, pure DC is a straight line, but after the full wave rectifier you are getting this kind of DC, which is nothing like this. So basically it's a pulsating DC. So it's a pulsating DC. Okay. The forbidden energy band gap in conductors, semiconductors and insulators are Eg1, Eg2 and Eg3 respectively. The relation amongst them is, so forbidden energy gap for conductors is in Eg1. So Eg1 is conductors. So let me write EgC1. Okay, and Eg2 is semiconductor. So Eg2 is semiconductor. Okay, so Eg S2 and Eg is insulator, so Egi3. So this is how I can remember it. Okay, when I have to compare, I have to think, right, which one is what. Now forbidden energy gap for a conductor is 0. Okay, for this it is slightly I think 3 electron volt, less than 3 electron volt, and for it is greater than 3 electron volt. Okay, it is less than 3 electron volt and it is greater than 3 electron volt. So definitely Eg3 is highest, so Eg3 will be highest, so it will have this arrow towards him. So Eg3 is highest, Eg2 is in between and Eg1 is lowest, so option C is correct. Okay, now the energy band gap in germanium and silicon in electron volt respectively 0.7 and 1.1. Okay, so sorry, first germanium, right? So first germanium and then it is 1.1 and 0.7. Okay. In a semiconductor, the concentration of electron is 8 into 10 to the power of 14 centimeter cube, and that of the holes in 8 into 10 to the power of 12 centimeter cube. The semiconductor is P type, N type, intrinsic, PNP type. So it is given that the holes, the concentration holes is much higher, concentration of electrons are much higher than that of the concentration of the holes, right? So electrons are highly concentrated compared to holes. If you see that it is per centimeter cube almost 800 extra electrons, so definitely it's an N-type semiconductor. Which of the following energy band diagram shows the type 800 times, sorry. So which of the following energy band diagram shows the n-type semiconductor? So n-type semiconductor has a conduction band, valence band. I think somehow it is inverted. So conduction band, valence band, conduction band, valence band, valence band, conduction band. Okay, so what is the n-type semiconductor? N-type semiconductors have electrons level which can easily jump to the conduction band and conduct. These are electrons, that is the donor electrons. So this is called donor level. This is why it is called, this is the correct diagram for n-type semiconductor. Now if you see this, in this case they have reversed it. Okay, in this case they have reversed it. Conduction band and valence band actually reversed, inverted, which is not possible. Conduction band is always higher than valence band. Okay, and in case of this is for n-type. For p-type there is a acceptor level. For a p-type, this is conduction band, this is valence band. Okay, there is an acceptor level which can accept electrons, and it creates holes in the valence band. Okay, this is how it works. Which of the correct diagram for half wave rectifier? Half wave rectifier works only one diode. Okay, so if you see in this diagram, so when it is positive the current is passing through this, and negative current is not passing through this. So option B is the correct answer. Okay, next, and if you wonder what about our weekly schedule, here is the weekly schedule for all of you are expecting. So I have given my personal weekly schedule at the beginning of the video. Here the weekly schedule of the other teachers. You can pause the video, check a screenshot, and understand when other classes are happening. By the way, if you have not joined our WhatsApp channel, don't forget to join our WhatsApp channel. The entire PDF will be given to our WhatsApp channel. And if you have not yet subscribed to our channel, definitely subscribe to our channel. More and more your pure preparatory videos are coming in our channel, so don't wait. Subscribe to our channel now. I will be back with the next video very soon. Till then, bye.